All right. I got the hiccups a little bit, but let's get started here. I'm gonna get a drink real quick. Pour it over some ice. If you guys want to do some Linux, we are going to be focusing on systems today, systems admin, and we're going to go over something that we were doing the other day, and that's what a Linux administrator needs to know about these different topics. We're going to start off over in the presentation we were in yesterday, and then we'll come back over and do some of this Linux admin security stuff. So we're just going to, I don't know, do a whole bunch of Linux stuff today, right? That's going to be kind of the goal. If anybody's got any questions, let me know. I try to help you guys out where I can, but for the most part, we're just, oh, excuse me, freaking hiccups. For the most part, we're just going to work on all this stuff. There's Ranger. But let's start down here. It's where we were yesterday. And if you were around yesterday, we were doing Linux systems admin, and we went through what an admin does, how we check resources, how we validate that the system's pretty healthy. And then we got down to here, and this was about the time I was tapping out, 2 hours in or so. The next part to talk about are testing methodologies. How are you going to test things? You know, you want to see if a system's better, or you want to baseline some test system that maybe somebody gives you to build, or your company wants to test between a couple of loaner systems maybe they have. There's a bunch of things that you might get in your career. So you want to test things. Typically when we test things, we seek to find and record accurate information about a system, whether it's the one that you're currently on and you're baselining it, or the new one. A good testing methodology is going to ensure the accuracy of that information. Whatever you're doing, right? Whatever type of testing methodology really that you're working with, you want to scope down to only collect the things that you want to collect and not listen to all the noise. I mean, look at this real quick, just for a second. There's so much noise in some of these. I'll move this over just a little bit. There's so much noise in these. It's not that they're bad. There's just a lot of things happening. That's good for the right reasons to look at this type of graph, but for the average person, this might be way too much information. You might want the normal person to look at this and just see number go up, right? Graph go up, problem. Graph go down, fine, right? And then you could use that to determine things, right? But the point is how we scope and collect only the things that are pertinent to what we're trying to figure out. How do we then collect it? If we're collecting things, are we collecting them in a proper way with good instrumentation, right? In research, we call it a good instrument, right? If you don't have a good instrument, nothing else is even important. Boris, how's it going? Hopefully this stuff's useful to you. Yeah, we're just kind of, I guess you would call this a continuation of last night. I think I even put I put a part 2 on it for today. Let me check over on YouTube. Yeah, I put part 2 because this is just a continuation of what we were talking about last night. If you're going to collect things in the proper way with the proper tooling, you know, if this is, you know, if this is so many inches, it should always be that way. You shouldn't have different types of rulers. You shouldn't have different types of measurements. You need to agree on the way that you're collecting things and what's important, right? And then how do we store it? Are we storing it in a safe place that can't be changed easily? Do we aggregate over time? Are we looking at a sliding window of time for certain things that we're looking at? And then controls are things in research. Controls are things that are there that should stay the same between multiple groups. Some people like to call this treatments and non-treatments of groups. And then with that, you can do what's called like difference in difference type. It's called DID, difference in difference type conclusions about what happens with a group with or without treatment. And then you can determine if that treatment And I'm not, when I say treatment, I don't even mean medical treatment. I'm saying a treatment of some type. Something has happened and we are measuring it against two different groups, right? So that's like the collection of data. But in the purpose, we write up why we are doing the test. In the scope, how are we conducting the test? What's being captured? You know, if I'm trying to measure the size of all the straws that happen to have gotten on my desk over the last few months, here's all the straws. And maybe that's what I want to, maybe that's like the size of these things that I wanted to keep track of. What might be out of scope is the restaurant that they came from, or what might be out of scope is the quality of the paper that they're in, or the color of the straw. Those may all be out of scope. I may only care about the length of straws that are provided by different fast food restaurants or whatever, right? That could be something that was interesting to me. Again, I don't know why it's interesting, but that's what we call scoping the test. We scope and then we know how to collect, right? What we want to look at. Out of scope, what don't we care about? Sometimes we acknowledge it. Sometimes we acknowledge, yes, these are from many different places over many different months, but we wanted to see the difference, right? Or whatever. Sometimes we acknowledge, but we don't record things, right? And maybe we know why. And then if there's an anomaly occurs, is it something that we did not consider, right? And you should acknowledge that anomalies can occur. There can be, like if you're testing systems, if you're doing like process controls, there can be 100 output, right, of a thing. And every single one of them can be between a recorded value of like 3 and 6. So now you've got this upper and lower control limit. And one thing comes out, and I don't know what you're measuring, maybe the centimeters around or whatever it is, the same instrument of a thing. And one of them is like a high outlier at like 99. We could probably realize as we're drawing, a linear regression through that, right, and kind of finding the average points, that we probably should throw that large outlier out. Otherwise, we're going to have a bunch of data points like this, and then the line is going to go up like this for no reason, and it's not going to make any sense to the data. So it's definitely not going to be good for future predictions, right? So, like, what's in scope, what's out of scope? Are we dropping in a class of 30 students? Do we drop the 2 highest and 2 lowest scores, right? And that kind of stuff, right? Like, when I give, I know this isn't the best way to do things, but I kind of play these games with these things. I never give, like when I do surveys, I don't just give 10, 10, 10, 10, 10 across the board. Now some of you are in the service industry and you're like, you son of a bitch. If I don't get all 10s, I don't get whatever. And I'm like, well, then honestly, it's the company fucking you, because that's bad practice. It's bad practice. If everybody just gives 10, you have nowhere to improve from. It's like when we were talking the other day about the self-assessment. If you go down that self-assessment and you say, I'm all 10s, man, there's nothing for me to learn, then I go, well, congratulations, you're king of the engineers then, because there's nothing I can teach you, certainly. Maybe you should go hang out with some of those guys that like do this stuff all day that are just, trying to see who's the best at talking about being an engineer, right? So anyways, out of scope. Methodology, right? Description of how we will work to objectively determine quality of outcomes. So the way I like to think of this is, I was telling you guys this about like a movie the other day, right? Like, let's say, because my wife gets really mad at me. Like, I'll tell her I just finished, right before I started this stream, I finished a movie I haven't seen since probably 1998. It's called Half-Baked. I forgot how terrible that movie is. But I can't tell my wife that's a terrible movie, because I call all movies terrible. So my wife's like, we need to have some kind of list, some kind of way. You can't just say every movie is the most terrible movie, Scott. And I go, well, yeah, I can. And she goes, no, you can't. That's being subjective. And she's right. She's right. What if, like I've got like a white monster in here, right? And what if I took this drink and I just said, that's a really good drink, and I passed it on down the line, and everybody's like, well, Scott said it's really good, so I tried it. Everybody tries a white, but some people don't like it. Well, what if that's very subjective, right? Like, what I think is good or bad, that's not in any way something that we could test, right? That's subjective. But what if I said, in the area of like size of a drink, it's 16 ounces, and 16 ounces is perfect. But maybe if something's 12 or 8 ounces, I don't think that's perfect, so I give that a little bit lower score. That's now objective. I am telling you why I think something's good, and then there's objectivity to it. It's no longer just Scott thinks something is good or bad. Does that make sense? if I said, is it carbonated or not carbonated? Well, it is carbonated. It's got some fizz to it. So, okay, I like that. Therefore, I say that's good. If I give you the objective results, however, people may, as they go down the line, say, oh, Scott said this is good because it's a large drink and it has, fizziness to it and maybe a whole bunch of caffeine that keeps them all pumped up or whatever. Whatever your thing is, right? The point is that's methodology. And are we using qualitative or quantitative results? Now, qualitative is like low, medium, high. Low, medium, high. And low may be green, medium may be yellow, and red may be high. And we may use colors, and then we build color charts and stuff like that. That's qualitative. Qualitative assessments are very valid. A qualitative assessment can be a very good way to assess risk and all these other types of things. But quantitative is by the numbers. So 80% chance of occurrence, 90% chance of occurrence, or 90%, or we take in some risk account, and then we take, it happens once a year, and there's a 10% chance of it happening, and when it does happen, it costs us $100,000. So now we take that year, 10% chance, $100,000, and we say, okay, there's a 10% chance of it occurring. We are carrying $10,000 worth of risk throughout the year on that thing happening. Do we mitigate that or do we not mitigate that based on that, right? And some of you guys have seen that. I've got discussions on that. Hold on real quick. I'll pull one up real quick. Since I'm just going through old discussions anyways. I literally hate the name of this, but I'm going to show it to you guys. So this one's called Hacking and Risk Management. It comes from a quick talk I gave to some of my students years ago. And really the things that I care about this are right here, risk management. And this would be like a quantitative analysis up here versus a qualitative analysis down here. Both of them have their own reasons why they're valid. Qualitative analysis, you need experts doing it. Quantitative analysis, anybody can do it as long as they're getting good numbers. If they're being given bad numbers by your organization, nobody can do a quantitative analysis. But qualitative requires it's subjective to the expertise of the individuals doing it. And you're going to get different answers from different people, right? You can also turn these into like heat maps. These are real good for like colored heat maps, right? Like I was saying, maybe green is like a low risk. This may be yellow in here, and then these might be high, and those might be red, right? All right, get that out of the way. And then a control is what's going to be put in place to ensure the collection is done against a similar environment between tests. In engineering, in economics, this is used more, but I like to use it in engineering too. It's ceteris paribus, and what it means, it's okay. Ceteris paribus. Fine, that'll make it spell it right. But this means holding all other things equal. Meaning, as best we can, we try to test the system under the same conditions, under the same amount of load, at the same time of day, whatever the thing is. It's almost like the ceteris paribus is give everything a fair shot. Like don't just skew your numbers for one test. Some people, anybody here ever like done bowling? I've seen bowling in leagues before. I've never like played on a league team, but I've seen people bowl. I've been asked to come bowl, like, because you can just be an alternate or whatever. Have you guys ever heard of sandbagging? Anybody here know what sandbagging is? All sandbagging is keeping your original numbers low so that when you actually do bowl, you go against a better handicap and it bumps your numbers up higher. Have you guys ever seen that? And then it becomes a moot point if you can bowl 185 or higher or something, because I think you don't get a handicap above that. But to sandbag would be, let's say you bowled on average 185, but early on in the season you only bowl 120s. And then now when it comes time and you bowl 185 the whole time, your handicap's pumping your numbers up, so you're beating people. I think that's all silly, But, I don't play in leagues, so that's probably why I think that's silly. I bet people that play in leagues think that's really fair, and that's probably fine. That's a control, right? All right. So anyways, that control, by the way, I don't know if anybody here's ever raced cars on a track. Now, I'm not talking racing on the street. I'm talking racing on a real sticky track, the type that'll pull your shoes off when you walk on it. And my son used to drag race out there on those with his grandfather. So when you go out there, you find out that you race against your own time. You don't even race against the car next to you. And if you say, what do you mean by that? Well, go look it up. You only race against your own time. And if you beat your own time, you'll win against the car next to you, because that's how the lights actually go when you're just out there racing on a normal track. It's kind of an interesting little thing that they do. But all right, so that's testing outline. Let's talk about benchmarking. Benchmarking is going to use tests. So we're going to write up tests to look at how we're going to improve things in our system. Now, normally baselining is a separate concept, right? We're talking benchmarking is when we want to pump our system up. We're going to test the capabilities of our system. We're going to push the gas pedal all the way down to the floor, as it were, right? Also, by the way, I kind of just started. I didn't really go over into our Discord. Guys, we did hit 4,000 people in Discord today, so that's kind of cool, right? You guys are all welcome to hang out down there. There is a security engineering project intensive running right now, so the guys are actually in there studying and working on stuff. It looks like there's people down there working on stuff now. All the events in our Discord are free, so you can go to any of those. And these will always show in your time. So you're seeing them in my time, but they'll show up in your time when you do whatever you do. Okay. We got all that stuff. Yeah. So that's for you guys. Anybody that wants to join the Discord can. Let's get into benchmarking. So benchmarking and baselining are terms that people tend to use interchangeably, but I don't really use them interchangeably. I think of the baseline as the observability of your system, how it works under normal operations. So your baseline is like your resting heart rate. How does the system perform throughout the day on an average day? That's my baseline. From our baselines, we'll get high and low watermarks. So over here, let me pull up this. Hold on, this one here. Across this, we may see this is what the average day looks like for our system, and the high water mark's actually pushing pretty high on some of these, especially on the CPUs. Memory is not pushing nearly as high, so the high water mark for this is probably only around 57, 58%, somewhere in there. There's a couple that have spiked, and they've got a little bit higher high water marks, but on average, our daily system usage for CPU and memory is pretty low. Right? We don't see that all that high. And but they do spike up, and do we know why they spike up? Sure. We know that there's a antivirus running in our cluster that checks for things and that kind of stuff, right? Uses Clam antivirus, which is a open source antivirus tool, but it's provided by Cisco. Owns them. Cisco bought them, so if you didn't know that, Cisco owns them, and you can tell that if you ever need to. If you're ever looking for anything. Clam antivirus, right? Clam looks very open source-ish. Then you go down here and you see that it's owned by Cisco right there. So Cisco bought them a few years ago. And then you can get they're open source, they are, but their virus definitions are not open source. Or to put it a different way, they are released later. They are not released to general consumption, I think, until like a month later, typically. And you can read about all that if you want. Yeah, you can learn to read. Oh, you can learn to read and write your own Clam AV signatures if you wanted to. So there you go. Here's their signature writing manual. It's kind of fun. That might be a fun project for somebody on the security side. You know, we got a bunch of people doing these security projects and stuff right now. That might be a fun one right there. They can go write their own databases. Never heard of that backup software before. What is that? What's the Clam AV or Clam? Okay. Where was I going? So low watermark, and then baseline should be captured with telemetry and observability so that you can see the system over time, right? Benchmarking, though, is about pushing your system, seeing what the limits of the system capability is. These do negatively affect system performance, so you need to watch when you run them. You should not be running these in production systems. Well, not if you don't want. I run amok, I probably missed whatever it was. I was probably talking too fast, but often benchmarking is about stressing a subsystem to determine what it can do in the real world. In a perfect world, this is done prior to going live and will provide data that will let us answer what is normal performance. Now, the thing about benchmarking a system is if you stress test a system, right? You stress test a system as hard as you can and nothing breaks, all you did was a load test. A stress test must cause something to break. Something must shoot a spring out the side. a process must fall over, an API must, crap itself and stop connecting or whatever. Something has to happen for you to call something a stress test. If you do everything as hard as you can as far as a stress test goes, and the system handles it, all you've done is prove load capacity. You did a load capacity test. That's it. You did not do a stress test until something breaks. So remember that. That's the difference between a stress test and a load test. You may be trying to stress test a system and find that you can only push 5,000 connections to a server with maybe your hardware, and the server handles that load. All you've done is prove that your system can handle 5,000 concurrent connections. That's all you did. You did a load test and your system passed the load test. If, however, you go to that 5,001st connection and your system falls over, that's now a stress test. And then you got to go find what stressed it to break. Was it that it couldn't allocate a single more TCP connection? Was it that you got to go figure it out, right? It could be anything, but that's the point. This is what benchmarking's for, right? Seeing how the system behaves under normal performance. Okay. So here's a benchmarking iteration. This is kind of a methodology that I use. Benchmarking goes like this. We plan out, what are the goals? What do I want to prove about this system? Do I want to prove that this system can do, do I want to prove about this system the maximum I/O to the disk? That's a common one that we try to do in the high performance compute world. We're using Weka, or we're using Lustre, or we're using GPFS. There's all these different types of file systems, and we want to test how fast I/O can go in or out of that system. That might be something we do, and that may be my identification of my goals right there. I want to test the system in the state that it's in, under low use, normal day, whatever. Boom, hit it. Then if I know that that's what I want to do, then I got to go get my tools and my metrics. My tools are what's going to collect, and my metrics are the measurements I'm going to use. So I mentioned this yesterday, but I always have to, if you're ever talking about this in Linux systems, you have to give a nod to this site. It's required. It's like required by law. It's like a Linux law. You have to look at brendangreg.com and see, hey, you wanted to do disk I/O? Well, here's how we start to check that. IOStat, BioSnoop, there's all these things. That's block devices. We can go see all of these different types of things with these commands. So many good commands on this site. I can't even stress how useful that is to get into this stuff, right? So I'll link that to you guys that want it. Yeah, it's not a stress test until something breaks. That's true, Chris. Yes. Yep. There's no passing a stress test, I suppose. No. Well, no. What would happen is you would be trying to stress test your system, and it would handle the load. So then it would almost be like it immediately went from Jekyll to Hyde, or Hyde to Jekyll, whichever one is the good one, and it only became a load test. You could have been trying as hard as you could to stress test that system, but if it chewed it all up and took all the load and didn't break, then it's only a load test. Yeah. So anyways, that's Brendan Gregg right there. That's a great site for getting into. Some of you guys want to do like eBPF and discovery and tracking things at the kernel level, and that stuff is very, very common for looking at containers and Kubernetes. So Kubernetes and all these pods and containers are moving around, but we want to see like the raw system calls that they're making down into the Linux box. Those are the tools there that would show you the eBPF tools on that site. So anyway, so yeah, your goals, whatever you want to track. I want to see how many, I don't know, you might have one. I remember I used to do this on systems when I was younger. I just want to see how many browser tabs I could open up. And one of my stress tests for a box would be like open Word 100 times, open Excel 100 times, and open like 100 tabs on a Chrome browser and just see. Typically crash on the Excel, right? But I just wanted to see if my system could do it. And this was the thing I used to do. Messing around. I used to use Python to just spin up stuff on Windows boxes. I thought it was funny. But then we'd have our tools and our metrics, and then we're going to plan and do some resource allocation. Maybe we plan to do this on a Friday at 5 p.m. when people shouldn't be on the system anymore, and then we go from there. Then we get to our experiment phase. We define the experiment. What's the number of servers? What's the scope? This is scoping down to exactly what we're doing. We execute the experiment, and we collect the right results. If you do an experiment but you don't capture any results, then a lot of times these go, when we do file systems, there's certain government projects and things that are write once, read many. We call them worm file systems, WORM. It's write once, worm. Yeah, write once, read many. But we joke around about write once, read never. But anyways, my point in saying that is, you do your experiment definition. You know, these nodes, we're going to test their speed into the system under a low usage time, not like when everybody's watching their cat videos or whatever. We're going to execute the experiment and get the results and analysis of the system. Then we're going to make a decision. Maybe we decide that, okay, this is our baseline now. This is what our system is. And maybe we were about to put in a new disk I/O controller or a new JBOD, just a bunch of disks. And we were going to connect it into some system. And we expect to see, obviously we're going to see the extra disk space. The space will be there. But now we've got more channel paths for our I/O and maybe another couple of RAID 6 blocks. So we expect the I/O to go up in that system. And we've done the math. We've talked to the engineers. We've read some stuff on their online documentation. And we say, well, I think with this version of an operating system and this network and this GPFS version and this number of, you know, cluster JBODs or whatever we're using, I think that we're going to get about a 16% increase on this. And maybe that's even what you sold management. You said, hey, for this $10,000 or $15,000, we can up this storage and probably squeeze this much of a percentage out, right? But here's the thing, when they're all done and they've got to go answer for how that system actually worked or how well it worked, you need to be able to then prove that the thing did what you said it was going to do, right? So this is why you do a before. So you do this here. You do a benchmark report. You improve. You plan your improvement. Maybe you do whatever the other thing was that you were changing. And then you do a monitor to make sure, and I would even execute the change or the experiment again and make sure that the change did what it was supposed to do. That's what I would do. The other way, if we weren't talking about specifically an update, is we might experiment and say that a system can do this much stuff, but then we clean out all of this other software that doesn't need to be there anymore, and we expect it to yield about a 5% lower overall CPU usage. We prove that that happens when we clean out all that stuff and turn off all those additional services, and then everybody gets a nice little report that shows across the board we have cleaned up, you know, these 80 servers and given them, you know, 40, maybe, I don't know, however many less percentage CPU, which should yield an extra maybe 120 connections or something. I don't know. Whatever the thing is that you're doing, you have to figure out, you know, and this is why you've got to just understand these things and figure out your own methodologies around what you're tracking. Sometimes when you start benchmarking, you have no idea what the system does. You have no idea what the speed is. You have no idea any of that stuff. Some benchmarking tools that exist. A very common one is Top 500 LinPack. The LinPack is the standard right here. This is the one that we use, the LinPack benchmark for high performance compute stuff. So I'll link this to you guys that want to go look at it. And what the LinPack does is it tests for a thing called flops, floating operations per second. And then once you hear that term and know what that means, you'll see it everywhere. Let's go to like the top 500 list for this. One was just published for June. So these are the fastest supercomputers in the world right now, right here. El Capitan is still number one from Cray. It has 11 million cores, and it's petaflops, right? So petaflops are 1.742, right? 1.742, and that would be then what up into exaflops, I believe, are above petaflops. If I might be wrong on that, but anyways, they're using petaflops, so we could do petaflops. It's 1,742 of those, and you say, is that fast? Well, let's go look at it compared to some of the other ones. By the time you get down to 5, he is 5 times fast. So he is faster by himself. Well, not than all of them, but for sure any of these lower two down here, right? And he's pretty fast. That was pretty fast. And then how much power is he consuming? Massive amounts of power. That's his kilowatt hours right there. That's 29 megawatts, right? That's a wild amount of power, guys. That's like, I'd be willing to bet that's more power than some countries do. And I don't know if you guys have seen that, but if you look at, there was a thing on Reddit a few years back where it was like the amount of electricity that was being used in Bitcoin mining versus the next, like the lowest 130 countries in the world, and the lowest 130 countries in the world were using less power than all the Bitcoin mining operations that were going on planet Earth. And I was just like, oh my god, wonderful. Anyways, yeah, Cray is out in front with their El Capitan system. The one that was huge for a long time was this supercomputer Fugaku. And the thing about this one that's so powerful, the reason this one was so interesting when he took #1 back in like 2020, this you can go look at the history of this one if you want. This one is an ARM processor. This is not these ones are all x86 64, I'm pretty sure. I'm 100% sure these two are. Pretty sure. This is an ARM processor set. These are all ARM processors. So, totally different architectures, guys. Yeah, exaflops. Yeah. So this one's fun, right? This is one. I have stuff that's on this. It's not right here. It's not in the top 10, but I have things that debuted like in the top 30s on here on customers that I've worked with and stuff. Could arc across a 2,500 foot gap. Yeah, it would be a true Tesla coil, wouldn't it? It's almost half a mile. It's pretty wild. Okay. So my point in showing you guys is this. Your admin skills might not call for this when you're just doing normal admin work. But when you tell me, hey, Scott, I want to, I do want to be an engineer. I do want to be part of the planning of systems. I do want to make those things better. I'm going to tell you right now, you don't have to get any smarter. You don't have to take any more math classes. You just got to go figure out these methodologies. And then from there, you need to start working up, how you, yeah, there is some basic math that's involved, but you can do that math, right? You just got to go start the methodology. You got to collect things correctly. It's like this. You know what's funny about this is if you ever go take that Gremlin Chaos cert, there's a cert that actually we need to make another bounty on this for people. There is a cert called the Gremlin Chaos Engineering right here. It's free. One of the guys went and took it in like 2 hours or something, but I would tell you to spend like 6 hours on it and then take the test because I think there's some good info in there. One of the things you learn when you start studying chaos engineering is the first thing they say is this is all the scientific method. We're just using the scientific method. This is literally the scientific method. That's like what it says if you go read any of this stuff. It'll just start off with this is the scientific method. What are the principles? Plan, conduct, scale, or squash. It's the scientific method. It even says it, right? They start to teach. Man, I tell you guys, like, if nothing else, right? As engineers, you got to know how engineers talk. This is not like me saying like, oh, come buy stuff in the Discord. We don't sell anything in the Discord, right? You can go hang out there for free. You ask anybody around here. I'm not charging you guys to hang out in the Discord. There's none of that. But you have to know how engineers talk when you talk with other engineers. So going and reading these things and working through these things will pay you dividends if you want to be an engineer. Everybody tells me they want to be, like, everybody wants to make engineer pay. But not everybody, I think, wants to put in the work to be an engineer. And you say, you got to go to school for that. I know plenty of engineers that didn't go to any school. They went to the school of hard knocks and they figured this stuff out. Some of them have been coming to the Professional Linux User Group for a long time, right? There's those kind of people. But my point in saying all that is you can do this stuff. Oh, man. Oh, I'm yawning. So, benchmark methodology. You guys can do this stuff. All right. Let's keep going. Here's some benchmark tools. If you want to benchmark your network, you can use a tool like iPerf. I actually think I need to set that back up in our home lab because I think I'd make you guys connect to one of the machines that's out there and I'd leave its system open. But iPerf will test. You have to have a server and you have to have a client. And then typically it's best if you know what's in between them. But if you don't know what's in between them, that's fine. It'll still show you the fastest that it can push data over UDP or TCP. You can do all kinds of different types of connection testing. I think I told you guys the one time I got called up. I was still working for one of our customers, And I had a little bit of time over lunch, and my boss called me up, and he's like, hey, on this unrelated project, can you show me some of the stuff with AWS that you do? And I go, yeah, what do we need to do? And he goes, well, I need to test a 10 gig pipe into one of our customers. So one of our customers that does climate stuff, can't tell you their name. They are the customer that will not be named. That's actually what we call them. They have 2 pipes into their organization. They've got their primary, and when I say pipe, I mean their network. They have 2 networks in. One is their primary, and that one tests at about 10 gigs every time they test. But he doesn't have any proof that the second line in is operating at 10 gigs. And he goes, Scott, can we prove that? You know, he's like, you got some time? I was like, yeah, I got a few minutes, you know, like 30, or it was like an hour over lunch. I was actually sitting in a meeting and people were doing stuff, but they were going slow. So I said, yeah, I hop on. So I hopped on a call with him and I showed him some stuff with AWS. And when you go to AWS, you can set inside of your AWS. So you can set the thing for your EC2 instances. They have 10 gig connectivity that you can get for your EC2 instances. You just need to make sure, that you're using the right size of instance, right? So here's some instance bandwidth, and it all has to do with the type of card that's connected, and I'm forgetting the name of that card right now. I'm waiting till I see it again. But anyways, here's the speeds right here, and they tell you can come down actually and size them and see which ones have whatever speed. So we needed a 10 gig network. So we needed a certain one, and we'd pick the smallest one that would give us a 10 gig network, right? Me and my boss. And then we flipped their network. This was a test network of theirs. We flipped one of their machines over to their backup network connection, put in this other VLAN, and dropped it. And then we did a speed test up into our cloud. Well, we did the speed test. Sorry, first we did the speed test the regular way. Saw 10 gig speeds. Well, we knew that was 10 gigs, so whatever. Then we flipped that machine over to the other network, and we were not seeing 10 gig speeds. We were seeing like 300 megs or something. And then my boss goes, hold on a second, hold on. And you tune out the way that you use iPerf to go across multiple connections. And he was peaking out right at about 10 gigs then. So there was a difference in the way that the setting, the way each individual flow was allowed to work through the network. There was some difference, but we were able to achieve and prove 10 gig Ethernet coming in, or 10 gig network coming in on both of their sides through this little thing. And we turned it on. We turned it off when we were done. It cost the company maybe 50 cents to have that machine on for that hour. It was nothing. It was nothing compared to what we got, and he was able to prove to the customer, right? Also, it was my lunchtime and it was his lunchtime. If probably, that would be probably about $500 worth of engineering time, right? If we were on the clock, but I'm salaried, so it doesn't really matter what my boss makes me do, and he's the guy who owns the company, so it doesn't really matter what he's doing. So basically, for 50 cents, we proved to a customer some deliverable that we had. By the way, it wasn't even related to us. We don't provide them the network connection. That was something else. We just had a deliverable checkbox to prove that it was the right speed. So there we go. Yeah, Akshan, I've been thinking about doing more. So the question was, can we get a stream for the Gremlin cert thing? I have my Gremlin cert, but I would definitely, if you guys were interested, we could throw together like a study group for it. If people want to go and study and get ready, we could throw a study group together one of these days, yeah. I'm super busy this week and weekend. We've got another party over here this weekend, but I can definitely do it. Also, real quick, how's Ranger doing? Ranger doesn't have much left in the tank, guys. He's an old dog, so we're just keeping an eye on Ranger, making sure he's all right. Okay. So anyways, iPerf is really good. It's like a ping pong. It tells you how fast you're connecting across and what your aggregate throughput is. And that's super important because we can have all kinds of theoretical throughput and we can have all kinds of like, this is the actual number of bits that we're supposed to get. But what does it matter, right? This is that old saying, one test is worth 1,000 expert opinions. You can say something, I can say something, everybody else here can say something, but we can go prove it right now, right? And that's what we want to do. And I got to set that up because in the lab for this week, I think, no, next week when we do the system baselining in week 12, I will have to have that back on so people can hit it because in the lab, in week 12, I actually make you guys hit that in the lab. Let me see. Hold on. Let's go look. Oh, there's some linear regression stuff. Yeah, here's some iPerf stuff. And I think I make you go hit... Yeah, I make you hit one of the nodes in the cluster just for some iPerf speed testing. And that's red 1. And I have red 1 off, so I probably should go turn that node back on. Oh, jeez, come on. All right. I don't know if that server exists anymore. Yeah, I might have deleted them all. That would not be great if I had deleted them. I'm pretty sure I have, yeah. I have to turn that one back on for this. Yeah, they're all gone. I'm pretty sure they exist here as yeah, they're dungeon templates. So I can stand them up. I can stand one of those up and give it the right IP address again, because those were the dungeon nodes. If you guys remember our dungeon work for a while. Hey hey Monkey Man, how's it going? Hopefully this stuff's useful to you. We're not working super hard tonight, but we are talking about Linux and systems engineering and all that good stuff. And specifically where we were was on benchmarking. You've got perf as well. Perf will tell you about how fast a process runs. So you do like perf stat for the pwd command, and pwd will output the working directory you're in, right? But it can also be used... Well, I gotta get connected back in over here. Get my home lab here. So here's my home lab, right? And I should be able to hop to this box. Oh, thought I would have had perf there. Oh, spell, if I spelled provides right. Perf. There we go. Yeah, so Monkey Man, we're just kind of hanging out and working through some stuff. So I've got perf now, so I say perf stat pwd, let's say, right? And it tells me what pwd did, how long it took, what it was doing on the system, all that kind of stuff. And that's slightly interesting. But what might be more interesting is maybe if I stat something like, I don't know. Maybe let's do perf stat something like what would be something interesting to us? So here's the output for IP adder up here, and here's what happened with that as we executed it, right? Here's the CPU utilized for that. Context switches, what part of a second it used. Were there any page faults? Any kind of stuff that was going on, right? Total time elapsed, almost nothing. The user space and the system space. Now that goes back to, remember, we've also seen this before with something like this. We can time how long something took as well. And time's reading off the same type of information as that. All right, so anyway, so we've got these tools to benchmark, but guys, just having a bunch of tools and just like, I thought I had a hammer up here. If I just have like a hammer and I'm just like going like this all over the place, you guys realize that that's not going to build a house, right? If I'm just like going like this, I'm swinging with my left hand, which isn't even my good hand, and it's not going to build shit, right? It's just going to go like this. It's the same thing, like tools without a purpose around them, nothing. You gotta have a specific thing you want to track down, right? Defined up here in your testing. Then you build your methodology out around that test and use the right instruments to gather the right information or metrics on what you're trying to measure. It doesn't make any sense if I wanted to measure my phone right here, right? If I wanted to measure how big this phone is right here, for me to pull out a thermometer and stick it on my forehead. It wouldn't make any sense, right? It's the same thing with all this instrumentation and tooling. It only makes sense to figure out what you want to track and then use the right tools to track that. And I know I might sound like a broken record, but people struggle with this, man. People struggle with this big time. If more people didn't struggle with this, I wouldn't need to be the one doing it, right? So, all right. You got benchmark type tools. You can use stress to stress the system and really see how it can behave under load. You can run stress against a certain number of cores or a certain number of, you can run disk stress. You can run all kinds of different types of stress and be running an application and see how an application behaves when there's load on the system, right? Does it cause the system to immediately fall over? Does it, if it can't write to disk, do the buffers work properly? Does it properly cache things? Like what does the system do when it can't get to the resources that it expects to be there? What does it behave the way we expect it to, right? You can also do DD. DD is a good way to waste your processor time, right? And in this one, I don't even have an out file over here. I just did a bzip or a gzip -9, which is the highest, and throw it all away, okay? We can DD to read in or out of the file system, and then I'll show you guys a little bit of that. And then we can read out of a file system as well. How long does it take to read a file? This is really big for SAN storage. I use these all the time for SAN storage. Big storage area networks and big, when we talk about what are called parallel file systems, I'll run these off of multiple machines at the same time. But always adhering to that thing I said earlier, ceteris paribus, where it's all about not changing anything that doesn't need to change. And I don't test my file systems during the middle of a big production run for the initial test, and then when they're empty later, and then I say, look at how much better my system's performing. Well, I mean, I guess that may make me look better to the boss or something, but it's not going to look better when push comes to shove later, and they're like, well, we want to put more stuff in, and we're at low capacity, but you've always been reporting the wrong numbers, right? It's going to make people start to question your engineering, and that's not good, right? So don't be that guy. Make sure you're doing the right stuff. All right, more benchmark tools. All right, and then this is practical application. This is the exact same things that we just showed here, but it's down here. So practical application. Maybe I have two systems. And I gather the current information, and I change table to whatever benchmark or baseline data I want to collect. But in this case, I wanted to see maybe my write optimization for different disks, and then my disk read, and then maybe I want to rebalance some stuff in the system, right? So this is the time it takes me to do those things between two systems. I make some planned change. Maybe I add extra disks, or I do some things so that reads and writes should be faster, theoretically. And then I gather new information. Now, I'll tell you guys one. This is a huge one. I've seen this happen a lot. So you've got two disk arrays, right? And they've got however many disks in them, maybe 40 disks each. And you're going to add a new disk array with 40 gigs of data, 40, maybe you're doing terabytes, right? So 40 terabytes of disks, 40 terabytes over here. You're adding this in. But then over the next week, you find that disk reads are still slow, but new disk writes, new data being written in is actually much faster. But the disk reads didn't get any better. Anybody know why that might be? The word's actually on this page right here. What you need to do to the cluster. This is a very common thing. There's a lot of tools for what this is, but you've got to do something to this cluster to make this work better. I want you to think about this. You only had two before. All your data was being written to those two. So now writes are going in and they're reading, and then they're writing against three channels. Resliver, or in this case, resilver. I've heard that term before. I think that's is that a Windows term, or is that just an old term? We call it rebalancing a lot nowadays. But yes, you're writing data in, and your writes are hitting three different channels to those storage arrays or whatever they are. But your reads are still only coming off of the two that had the old read data. If you rebalance it though, or resilver, I think is the term. I've heard that term, but I've never used that. Yeah, ZFS. Yeah. Now you've moved it across all of them. So maybe you had 10 terabytes and 10 terabytes, but now you've got 6 terabytes across all of them, or 6 and some change. Your reads are now going to come across all 3 as well. Even data that's like 10, I was going to say 10 years, let's say a year old, right? Because typically we also have other things we're doing with data that's not been touched for 90 days or something like that in big storage systems. But this is part of that benchmark practical. And look, you could take this and turn this into anything you wanted to prove and anything you wanted to fix in your system. You tell me right now, hey Scott, I've got a gaming machine, right? Pull something up here that some people may not have seen in a long time. You've got a tool like Perfmon, right? Yes, I know this is a Windows tool. And Perfmon, I can't tell you guys how many times over the years, I used to build systems for people, like gaming systems in the early 2000s. I actually ran a business doing this. And I can't tell you how many times over the years people were like, let's just throw some more RAM in it. I'm like, it's fair. RAM may make your system faster. It's definitely going to make your system have more RAM. But what if I told you, and you're into gaming, right? We used to use Unreal Tournament and all these things. There were games back then that were heavy on the IO. Don't think there weren't. What if I told you though that we could come and watch your performance when you start games up and when you do these different things? You could even do this now if you're a gamer, right? Why would you? But here's the thing: if when you start your system up, memory never peaks and CPU never peaks, but disk IO does. I can almost guarantee you that's true. Most systems, even with SSDs nowadays, you're reading so much off of the disk. And what if I told you that one of the best improvements that I used to make for people is I would take their main disk and turn it into some type of RAID array, and they would get so much more performance out of that thing. There's a bunch of different ways to do that, and you can look that up and stuff like that. Is there some cost to it? Sure, but if you're telling me like I just can't waste the half a millisecond aiming on somebody because my system slows down and gives me an artifact. All right, well, there's things that we can do, right? But my point is, don't just say, well, it feels like the system needs more RAM. That's not good. That's not good engineering. We were talking about that the other day. It's not good engineering to be like, well, I feel it in my heart. I feel that the system can just be faster with more RAM. That's not good engineering. Why don't we go look at where the bottleneck is when the behavior's happening, and make our decision that way? That's what we call data-driven results, right? All right. Anyway, so troubleshooting. This is a big one too. I think troubleshooting is maybe, especially early in your career, you're going to get a lot of trouble. People are going to throw trouble at you, right? You're a Linux engineer or a Linux admin because you can fix everything. That's what everybody's perspective of you is. And you say, no, it's not. They don't possibly think. Yeah, but they don't know what you do. I've been trying to show people. I've been trying to pull stuff up like this and show this to like management and people that I know for years, and they're just like, I don't read your words, wizard. That's what they do. They have no idea what you do, but they know you solve problems. So you're going to have a lot of problems as an engineer. In fact, the reason they're keeping you around for the most part is to solve problems. We went into that in one of our talks the other day, right? We were talking about like, people want engineers. They pay engineers to know stuff and fix things. That's what we're paid for. So the gist of that one is, how do you keep yourself, in there? But more storage closer to the Runnemucker. Does that character have a torch in their hand? It's pretty funny. All right, so let's talk about troubleshooting theory. I don't think I got to this. I think I touched this in a different way in one of my other talks, but let's go over it again anyways. There's many ways to troubleshoot a problem. Nobody's telling you got to do my way. Nobody's telling you got to do it only one way. But you should be able to, at a high level, talk through these 6 or 7 or 8 things. I've seen up to 9 different troubleshooting methodologies out there in the world, but 9 different steps to this same exact thing. Identify the problem and its symptoms. Sometimes you don't know what the problem is. You only know the symptoms. So you start to look around and figure out what you know. It's like that game of Minesweeper where you put the little flags because you know if there's a 1, it's got to be that guy. And if there's a 2 there and a 2 there, it's got to be that guy, right? Like you can start to, it's the process of elimination. That's literally what it is. There's a game I sometimes tell you guys about. Feel free to go look up this funny game from like the 80s. I had this as a kid. It's called Hunt the Wumpus. It's the same exact concept. You got to go find where the wumpus is out in the swamp, and for some reason you only brought one arrow with you, and for some reason if you ever miss, the wumpus immediately eats you. But anyway, but it's a puzzle game. It's a puzzle game based on this same idea. Sometimes you don't know the problem, you just know the symptoms. So you start to establish a theory of probable causes. That can be multiple. Then you start to test your theory to determine if you've gotten to the right cause. You establish a plan for resolving that problem. You implement the solution or escalate. If you can't fix it yourself, escalate it to somebody who can. I'll tell you one of the most, I mean, for your mental well-being, one of the worst things that ever happens to you is you get root in an organization. You become admin. When you become admin, you can't ever say, "Oh, I don't have permissions for that." Not on the Linux side of things. Yeah, I can say I don't have like an API key for an API, sure, but I can't say that I don't have like root access on a Linux box. I can do whatever I want. That being said, doesn't mean you don't have to escalate to vendors. Doesn't mean you don't have to escalate to somebody who supports the kernel. Look, if you want to write and deliver your own kernels internal to your company, you're probably the only person on planet Earth doing that. But, and by the way, you'd probably make way more money going and doing that professionally if that was something that you could maintain. So what I'm saying is don't get scared about tapping out and sending out for help, because all of us have something that we don't know about this system. I don't care how long you've been doing it, right? And then when you're done and you've implemented the solution, you verify functionality and, if possible, implement preventative measures. If the problem was somebody came in and tripped over a cable running across the front of our data center and that took out the whole data center, well, what's the solution? Well, obviously the solution is put a carpet down so they trip on the carpet and not the cable, right? It's simple, right? No, I'm just kidding. But the real answer is hang it at about neck high so they choke themselves the second time. Anyways, all right, I'll be good. But and then document findings, actions, and outcomes. Document. I would argue you should be documenting throughout, but at the end, codify your documents down. Maybe do an after-action review or a post-mortem, that kind of stuff. 1973, according to Wikipedia. Oh God, but Hunt the Wumpus was such a fun game, man. Like I was a dumb little kid and I figured it out. Velis IP, how's it going? Run amucker, you're still here, obviously. Velis said 20 years later, I have very little experience fixing things. I prevent them from breaking. Fair enough, right? In fact, we're going to talk about how to prevent things from breaking. I think. Yeah, I do have it in here. All right. So that's your troubleshooting theory. But let's go look at it here, right? Here's it visualized. Step 1, Step 2, Step 3, Step 4, Step 5, Step 6, and Step 7. They're all right there. Where do we start? Starting it's very good to start at the beginning of things, right? So we start to gather information. That information can come in from trouble tickets, historical data, log data, checking the system. You're just starting to gather information about what's going on. Then you start to identify systems. Well, this machine doesn't have the right IP address. Or this machine should be a bonded interface, and it's not, but all the other ones are. And then you find out that somebody was doing like a rolling update on something, and this one only went down, but the other ones didn't. Well, it makes sense. This one's maybe not bonded on two interfaces. And that would make sense then that if you were updating like your Mellanox drivers, that you wouldn't keep one of your two connections up if they're not bonded. That makes sense. I'd buy that as a problem, right, or something that could have caused it. Then we start to establish a theory of probable cause. We question the obvious. We follow and start walking through the OSI model. Now, let's kind of take a step back for a second. If I'm going to follow the OSI model, what do I need to know? Would it make sense that I need to know the OSI model if I'm going to follow the OSI model? So I'm going to show you that to you here in a little bit. Come down, test your guess, test your assumptions, right? Is it confirmed? No. Do we give up? Yes. Then we escalate and stop. No shame in that. Sometimes we don't have the right answer. Sometimes you've tested all the things, you've proven all the things you can to yourself and to the capability of your tools, and the answer is just it's the network's problem. Don't do that right off. But maybe you say, hey guys, I need a network guy on. I need network to tell me where this is going because I'm not getting. I've done everything else. I can see both of the systems, but they can't see each other. There's something blocking in between. And this happened to me multiple times in my career because we had a team. I told you guys this the other day. I was at a company, a big insurance company, and they were dropping in firewalls later to protect the PCI environment, and there's a long story to what happened that was wrong, but the point is, throughout the nights of many months, maybe even a couple years, as they were doing these changes, they did all the due care and due diligence they could, guys. They went to meetings, they tried to tell people, but stuff still broke. And when those things broke, we had to then go, well, we got a problem here, and somebody has to roll some things back or fix things. Hey, Enzo Bear, how's it going? Hopefully the stuff's useful to you. We are talking about getting into, Linux and systems. I think the title of today is something around like Linux for fun and profit or something. That's part 2. So we're just continuing stuff that I was talking about last night. Wife will be back in probably an hour, so I'll talk about this for a little bit longer. But anyways, you come through, you finally get it confirmed, and you start to establish a plan, set out steps, test it in your lower environments, and then make your change record. If it's an emergency, just you gotta test it as best you can and send it. Sometimes this happens, right? If the system's already down, the system can't pull over any farther, right? You guys all know this reference? Right? Can't pull over any further. The system's already down, guys. I'm not telling you that it can't get worse. You can delete stuff and it'll get worse. But what I'm saying is it's already down. We got to get it back working, right? That's not to say be hasty. That's not to say just go and do stuff. You still follow your methodology, but at some point you have to pull a trigger. You have to send it. We don't always go when we're ready. We go when we're ready enough, right? That was Colonel Graff. We saw that yesterday. Colonel Graff's from Ender's Game. He's not a real person. And I think Harrison Ford played him in the newest one. Well, the newest one from like 2013 or whatever. So like 12 years old still. So fix the problem or escalate. Verify the system works. Is the problem solved? No. You got to start over. You got to come back up here and go to your next most likely thing, right? Did it solve it? Yes. Could the problem have been prevented? Did somebody trip over it because they were wearing big clown shoes and you need to just not have that cable across the floor in your data center? Take preventative action. Now, before you guys say that's the stupidest example we've ever heard, Scott, why would anybody ever lay a cable across the data center? Fair. But do you know I was walking out of a data center once and somebody's like, what's that button doing? They hit it and it was the red button that turned off the whole data center. I've seen that happen before. Do you know what would have prevented that and was always there after that? With that stupid little plastic thing. You guys ever seen that little plastic thing that sits over the red button? That why is the power kill there in the data center? Anybody know? What's the thing? If you guys have ever been around, I talk about like if you take a security test, the CISSP, CCSP, Security Plus. I don't care what the cert test is. If they ever tell you, do you err on the side of protecting human life or do you err on the side of protecting systems? Do you guys know what's always correct? What's always correct on those tests? It's never been wrong to answer this on one of those tests. It is always protecting human life. Now, that's not true in the military, right? In the military, sometimes we got a mission to accomplish, and that is what it is, and whatever. But in the normal civilian world, the most important thing is the human life. So you hit the button and you save the person being electrocuted. That's what those are for. Now, also, wait, could you also save systems that are burning up? Absolutely. Like, because by the way, some of you probably also know this. If you're in a Class C fire, which is an electrical fire, you cannot put an electrical fire out while there's still current to it. Did you guys know that? You can suppress the fire, but you can't put it out. As soon as the suppressant comes off, the fire is going to start again. You guys know that, right? The sparks are going to keep happening, right? So you gotta cut connection to the open circuit. It's always true. All right. Anyways, I'm not here to teach you guys about data center stuff, but I could teach you about data center stuff. I've been doing that for a long time too. So we document findings and outcomes, and then we stop. You should have, in all good troubleshooting methodology, a clear start and a clear end to the methodology. There should be a clear start and a clear end to whatever we're doing. Okay? That's troubleshooting visualized. So let's go to, here we go. Troubleshooting methodologies. Good methodology should have a starting point, some process you follow, some string that you follow till you get to the end, and then if you need to, you can either start over or, again, if the thing sends you back through, you do it. And then the ABCs of investigation: assume nothing, believe no one, check everything. Right. There's a you can assume nothing, go validate it and verify things, and then believe no one. Make sure you test everything that you're shown or talk about, and that's check everything. So assume nothing, believe no one, check everything. Logical methodologies, right? Create a problem statement. What makes you think there's a performance problem? Well, the website's down. What do you mean the website's down? Well, it's returning a 500 error when I go to the server. All right, that's good. 500 error is better than a timeout, right? Why is that? Well, 500 error means that at least something's responding. You're getting a 500 back. 400's on your side, right? But that's okay. Has the system ever performed well? Oh, well, this started at 9 o'clock tonight. So, yeah, it was right until that alert went, and then users started calling. Well, that's a problem. That's Friday nights. It's always freaking Friday nights at 9 when I'm on call. So did it work before? Yeah, so that's a problem. Do you have a baseline reference? Yeah, the system was real high load before it went down. That's something to go look at, right? Has something changed recently? Software, hardware. I always look at RFCs, requests for change, or change requests as they call them, CRs sometimes. They will be in your configuration management database. But hold on. What if somebody didn't put one in? I've told you guys this before. I've gone to systems, right? And I always do this. I always do an uptime and a last. I've seen a whole bunch of people have logged into this one. Or a whole bunch of logins have occurred to this one since it last rebooted. And I go, okay. That's kind of interesting. But I've had this happen where I get called out and everybody insists there's no change. And I'm like, why are there 6 guys from that software engineering team on the call? It's like midnight. How did all those guys get on this call so fast? And they're like, well, we certainly weren't doing anything with the system. And you're like, all right. So you go do an uptime and a last. You see all their logins. And you're like, this just happened, right? And they're like, yeah, it happened at like 11:30. And you just got on. And you're like, you guys all started logging in that server on a Saturday night at like 11 o'clock at night. Were you guys doing a change? No, definitely not doing a change. I've heard that so many times in my career. And I'm like, look, guys, I'm not management. I literally want to get off this call and go back to bed. So tell me what you did so we can fucking fix it, right? Do I gotta roll this whole thing back and redeploy the whole software stack because you guys changed something? I just want to know so I can fix it. I literally don't care. I'm not gonna write the report that gets you guys in trouble. I'm just gonna get the system working and then go crawl back to sleep. It's actually funny. People, does everybody here know who this guy is? This is my character, both in our Discord and in my professional Slack channels. And people are always like, that guy's so funny. And I'm like, that's me, though. Who knows who this is? What's his goal? Anybody know what his goal is? What does Mr. Meeseeks do? He accomplishes his goal and then he ceases to exist. That's what I want to do. When I get called out or pulled into something away from whatever engineering duties I have, I literally just want to do whatever I need to do and then cease to exist to you. You could purge my name from your memory. I don't even care. I don't care if you never give me a award. I don't care if whatever. I just want to go back to doing whatever I'm doing. In fact, one of my favorite ones is this is one of my favorite ones. XKCD. You guys ever seen this one? This is the devotion to duty. Let's see if we can open image in a new tab. Make that a little bigger. You guys ever seen this? We took hostages, secured the building, and cut the communication lines like you said. Excellent. But then this guy climbed up the ventilation ducts and walked across broken glass, killing anyone we sent to stop him. And he rescued the hostages? No, he ignored them, just reconnected the cables we cut, muttering something about uptime. Shit, we're dealing with a sysadmin. That's what it's like. We literally just want to get the thing working and go about our lives. We don't want to hang out and talk about it. We don't want to do none of that crap. Just want to get the stuff working. This is one of my favorite XKCDs ever. There's some other really good ones, but this one's pretty good. That's it's called Devotion to Duty from XKCD, which is just a great site. Okay. Anyways, has it ever worked? What's changed? And then who is causing the load? We actually have a Sev 3 type alert, when people go into our login instances aren't where you're supposed to transfer data out of this big cluster that I run. We got like 2,600 nodes in 2 locations, and users will log in and then they'll start doing stuff on the servers that like spike the CPU and on all the login servers. And sometimes we have to send them messages and go, you guys aren't supposed to be using these servers for that. The data transfer nodes are over there. Go jump literally right over there via keys and do whatever you want. Stop doing it on these fucking login nodes. One of my buddies just sent one of those messages earlier today. That's a thing. So who's causing the load? What is the load average? Is the load average what we expect? Right? Is the load caused by IOPS, so input output to like a disk or a block device? Is it load average against the CPU, and is there wait time for the CPU? Is it latency on system calls or network connection, something like that? Where's the latency coming from if it is, right? And then throughput. What's our aggregate throughput? Something, has that dropped recently? Are we not getting the bandwidth out that we're supposed to because of like traffic shaping or traffic policing policies? And there's 2 different ways that and this, guys, is way outside of Linux. This is network engineering stuff now, right? If any of you guys are network engineers, you know when we have 3 VLANs that want to go out, like data, voice, and video, or multimedia, right? Yeah, we can have traffic shaping or traffic policing policies that either make the data wait or just chop it off, right? And there's all kinds of ways that we can do that. And then there's implications for retransmits that have to happen based on that, which can either congest the system more or not, right? We're not doing network engineering right now, but if you guys ever want to talk network engineering with me, catch me in the Discord. I've been doing that forever too, right? And it has the load changed over time. This is where I talk about having a good baseline, right? We can go and look at something like this, and we can talk about how these systems are doing. We can look for something like, if there's high load when there's always been high load, that's fine, whatever. But if there's high load in the middle of the day, now I have to go figure out what's going on. Something's aberrant. Something's changed, right? All right. So anyways, those are some other troubleshooting things. This one, you've probably gotten sick. Some of you guys that have been around, you've gotten sick and tired of watching this one. You've probably been like, Scott, you've talked about that literally hundreds of times. This is how I look at things. What's the utilization? What's the saturation? What's the errors for any one of the big 4? The big 4 are CPU, memory, disk, and network, in that order too. That's the order in which they'll run out. It's also the order of speed. CPU is the fastest, then memory, then disk, then network, right? So it's getting slower as you go down those. I showed you guys a chart yesterday, and if you want any of the stuff from so that chart was here, right here, right? That's the utilization, saturation, errors. But if you say, hey, Scott, can I get a hold of this? This is all up in the Discord. So let me go. I'll find that for you real quick. So if you go in the Discord and you hop down into presentations, it's right in here. Linux Systems Admin from 5/18 of last year. So just over a year ago. All kinds of talks. Every talk that people give in the Discord and stuff, people drop them in here. So people that came last quarter, my brother John that came, M-Pesa that came and talked to you guys about Ansible and Kubernetes and all those things, those talks are all up here. Some of them are even recorded on the YouTube that you guys can go watch if you wanted. So, all right. The OSI model, right? The OSI model, 7-layer model. It's by the ISO organization. The International Standards Organization has the Open Systems Interconnect model. It's the OSI model. It's ridiculous, right? So the ISO maintains the OSI. There's 7 layers. People remember them with all kinds of weird monikers and anagrams, and I don't know what to call them. But the main ones that I see people use are from top to bottom. Top is 7, bottom is 1. In a reverse order, all people seem to need data processing. That's one that I see often from students. From the bottom up, please do not throw sausage pizza away. Again, I don't think you need to memorize these like that. I think you just need to know what they're doing, right? We have maybe 2.5 hour walkthrough on the YouTube side for people that want to watch my network primer, and I go through all of these, right? But suffice it to say, if you understand the OSI model and you can ping a device, ping is happening at layer 3, it's packets, IP, right? IPv4 typically. You might be able to ping with IPv6 internal to some places, but if you can ping a device on layer 3, you do not need to check to make sure the cable's plugged in. You don't need to check to make sure if a wireless NIC is connected. You don't need to check to make sure that the box is on. The server's obviously very clearly on if you're getting to it via ping. So by testing here, you can cut the model in half. You don't need to check any of those because you were able to ping. Once you get on the box, you try to get out of your network. So I go to a Linux box, right? I'm SSH'd in, right? Once I go from here and SSH over to Rocky 19, I know that the network's up. I know up to layer 3 is working on this box. I don't have to do things like this and go, oh, is that IP address there? Is that IP address properly set? No, I know it is. The DNS got me there. I'm on the right box. So, but what if I was trying now to go out and I do something like ping www.google.com and I see that it has resolved a DNS name to a IP address, right? So it's given me an IP address. So DNS resolution occurs at layer 7 up here. So I was able to go from my device out, talk at layer 7 outside of my network, or maybe even internal if I have an internal DNS, and then I can do that. So that's one thing I might check, and then I go, okay, I was able to get there, but let's say I got the DNS resolution, but I still couldn't ping. That's a problem. That means that I was able to resolve, and maybe even internal to my own network, I hit a DNS resolve, right? And by the way, you can see where am I trying to go to resolve. I'm resolving outside of here. I can also do host. That'll give me information. NS lookup. That'll tell me how I got there. So the server I used was 8.8.8.8, which means I know that I got out to the world. But let's say I couldn't ping that. Next thing I would do is I would do something like IP route. See if I've got a route. I can also just do route. And then I would ping my gateway, 192.168.11 or .200.1, and I'd make sure I got a response from there. And then if I knew my next hop, I would check to see if I got a response from there. And then if I knew that, if I had gotten that map up here to this, then I would ping that, see if that came back. So I would walk my pings out from my location based on what I know by looking at the routes that I think are set. By the way, if I don't have a route set, that's probably what my problem is, right? Come to find out, maybe somebody set up a bonded interface and didn't reset the routes, or they turned on Network Manager when Network Manager doesn't normally run. Network Manager loves to wipe things out. It's one of the main reasons we used to turn it off in like Rel 7 and Rel 8. Rel 9 is a little more stable, so people do use it. But no, Network Manager used to always wipe our DNS configurations as well. I used to hate that, so I just turned it off. I'm not going to deal with it. Fuck out of here. I don't need you. I'm using Ansible for all my configs anyways, so. What's it to push one more file to a box, you know? Okay, so anyways, that's the OSI model. This one right here, symptom diagnosis solution, this one is much like being a doctor. And I'm going to tell you something about it after we talk about it. So look at symptom, identify the most likely cause, diagnose, and then treat it with whatever the solution is that you know of. The doctor, let's say you go into like an ear, nose, and throat specialist, right? And you're Mint here, right? And Mint has not ever been to this doctor before. But this doctor is an ear, nose, and throat specialist. And they know ears, noses, and throats. And guess what? Most humans, most of you, have ears, noses, and throats. Definitely have a throat. You can't breathe without one of those. Probably have your nose and ears on you. But let's just say, Mint, they've never met Mint before in their life, but they understand the human system very well. That's how this one works. If you know nothing about the environment you're in, you just get dropped in as like a new system admin, you can still use this one because you're an expert in systems. Does that make sense? I don't know everything about the system that I'm about to drop into, but I know Linux pretty well. And because I know Linux pretty well, There's not too many things that can be happening to a Linux server where it can be churning and not doing the things it's supposed to do that I can't go figure out what the symptoms are. You know, network's bad, processors are turned off, firewalls turned on and not allowing that certain port through. There's all kinds of things that we check looking at the symptoms until we find the right thing, right? And then we fix it. So my point in saying this one is effective if you are an expert or you know what you're doing, but you don't necessarily know the system, right? This would still work. This next one, systems thinking, this is the by far most challenging of all of these, because this one requires you to both be an expert in normal systems like ear, nose, and throat doctor, but also you need to be an expert in this particular system. So systems thinking is the process of analyzing all the interdependent components that comprise of a system. Look at all the pieces and how they connect. Does the system, what is the system supposed to do? And how does the data flow? What are the systems or devices that are connected? And for this one, we might look at something like this. Let's change this over to blue. You might have up here like a load balancer and some, out on the internet. Somebody might request in on port 8080, let's say, to your load balancer. Then your load balancer might be going to one of 3 different, these are all app servers, right? So these are app. And your app servers are sitting back here, and maybe they're all talking to, like, let's say this is AWS, so you got like an SNS or an SQSQ, right? So SQS, that's sitting here. And then that's going back to maybe that all just goes to like an RDS database or something, right? Which is an online transaction database, RDS, right? So my point is you have to be able to kind of visualize in your head where these things could be breaking. This is coming in and this is terminating your TLS. So your TLS cert needs to be up to date here. And then this traffic here is unencrypted, right? But maybe it's sticking when it goes to this system, this app, but it's not sticking when it goes to these 2 apps, and there's something wrong with that. And my point is, for systems thinking to work, you have to understand all the flow of everything. Are things being cached? Are they not being cached? Are they going to a queue? Are they not going to a queue? Are they going to a queue off of, there's all kinds of things that can be happening, right? So my point in systems thinking is you have to be not just an expert in all systems, but this system for this one to work. All right. So one of the things that was mentioned earlier, where's it at? I think it was Velis that said it. Let me go look. Velis said, 20 years later, I have very little experience fixing things. I prevent things from breaking. Fair. How a lot of people know how to fix things that are broken is this. They have experienced them, or other people have experienced them and know what might be broken. But this one comes from the military. I learned this also from the military and then later in college. And if you ever do any process engineering or process improvement type stuff, failure modes and effects analysis, the big one. It's a big one. You can go find all kinds of articles on it. But this is the general idea of it. It's a systematic process to examine what could go wrong, what impact might it have, what is the likelihood of it occurring, and what is our ability to detect and react or fix it if there's a problem. This is going to give us a systematic way to create an objective way of looking at a set of problems that could happen, right? There are 2 steps. Round up all the possible failures, right? Now, I'm not talking about all you and your friends. I'm just kidding. It's my friend's dad was one of our teachers in high school, and he used to talk so much shit to us. It was kind of funny. Just always talking down to us. Always like these little zingers and like little biting things. It was always super funny. Then we're going to assign scores to these things according to a standardized metric that'll give us, it'll yield us a number between something and something, and then we can objectively say what the thing is that we need to spend the most time with. All right? Yeah, my friend Jared's dad still teaches marketing at Ironwood High School too. But he talks so much shit to us growing up. He was even talking trash at Jared's wedding a few years ago. It was kind of funny. This guy his whole life is just talk trash to everybody. It's really funny. Hayes, that's what we keep you around for. All right, so failure modes and effects analysis. We'll round up a bunch of things. And this is one, I told you guys, this is one I actually did right here. This is really me writing up. I think this is about maybe a third of the ones that I found for a process that me and one of our other engineers that's around, sometimes Michael Pessa, me and him worked on this quite a bit. But we had these server builds, right? And in our organization, we had about 200 dev teams that would use our Linux servers. And they could at any time come up and push a little button. They were like one of those little, you ever seen those little rats in a cage and they could push a button and it'll give them like a little pellet of food? But if they push it a whole bunch, then it doesn't drop any food or something. I don't know, or it shocks them or something. I don't know. But the point is, these guys could push a button like this and a little food pellet of one server would pop down and it would give them one server. We had this ability. And actually, they could produce however many servers their teams were allowed to have. Most teams probably had the capacity to build about 30 servers at any given time. These servers were short-lived. They could be used for any testing that they needed. And then I think they were 1 month by default, and they could live up to 3 months if they asked for it. But what would happen is, when these servers would get built, they would automatically be put in that group's image and name and everything. And when that user went to log in, they would immediately have whatever permissions they needed. And if they asked for it, and if it was in a dev environment, we would sometimes even give them root to install stuff, right, for testing and stuff. So we had all this stuff like this. But in this server build process, there were all kinds of things that had to go right for it to work. And there were all these problems that we had. So what I did was I went and did an FMEA on the failure modes and effects analysis, right? You don't need FMEAA, but it's just so people can read it. So over here were the things that could go wrong. The initial image could be unavailable. So when the server got built, it took a golden image that we had prepared and had hardened from a place in ESXi, right? So ESXi has these backend storages called libraries, and it can pull a VMDK that we have hardened and put down there to be the base image. Sometimes those would be unavailable on some of the nodes. Who knows why? Storage can go stale, network connections bad. So what we did to fix that, this was the normal cause, was backend storage would be offline. Our normal controls were we would monitor vSphere systems to make sure they were always connected, right? If they were ever not connected, we would throw an alert and then call out the team and they would fix it. There's another one. This one was kind of somewhat common. Automation job kickoff might fail. That could happen for a few reasons, but the main reason this one would happen is like the service Ansible, like SVC Ansible account. The VRO or system credentials would be out of date. And because that could be a problem, what we chose to do as a control is we would just build all our servers at 5 a.m. every morning. All the server types that we had like 20 server types, Windows and Linux. We would build them all and make sure that we got a good build report from all of our system types. Because if they built in the morning, they probably would be fine on their credentials for the rest of the day. And if we caught the systems bad in the morning, a lot of times then when we would reset the password, they would be fine for the rest of the day because now they'd have the new password. So that was the thing that would happen. And you say, well, why couldn't you just keep the passwords up to date? Well, because we probably could have put like a calendar and a thing or something to remind us, but we were lazy. So anyways, the point is, maybe somebody missed the procedure, maybe missed the calendar invite. Let's just say any other type of error could happen, but this was the system error that would occur. So yeah, probably we could have worked around it. Now, another one was an agent register to the backend service fails. So you have these like Avamar and different types of agents, and maybe the version of agent or credentials that you have for that agent could be out of date as well. So what I mean by version is sometimes like New Relic or again, Avamar, maybe they've got a new version of the software and the old version has now finally versioned out and been too many versions back, and we've been building on ones that were still technically supported, but they weren't really good, and then it's finally fallen off, and then we have to go update our playbook or whatever that deploys that agent with the newer version of the agent. Sometimes we've already deployed it somewhere to test, and now we just need to pull that back into our pipeline, and nobody did it, so then to keep that from being a problem, our daily build process would normally catch that. So that was our current control around tracking it. And then sometimes you would get all the way to the end of the build, no problems, nothing happens, and you would do some final build checks, make sure you had your mount points, make sure you had your Active Directory connections and Kerberos tickets and everything, and then something would just break. Some unknown problem. Just wouldn't be good. and we would catch that before it got to the user. You don't want to send your users bad stuff. That's a waste for everybody, right? But sometimes we'd get to the end and we'd have some final build checks and they would just fail. So we'd go, okay, we can't send the server out, and then maybe we rebuild it and it would work fine. But the point is that's still a waste of time, right? So even if it only takes 5 minutes to build a server, that's still a waste of time to spend that 5 minutes doing that. So if the final build checks failed, that's a problem, and we don't have anything good around it, so we need to probably break this out further. So that was all my possible problems, right? This was the first step, right? Round up all possible failures, keep coming up with them, keep writing them down as you run into them, and now we got to assign some scores to them. So it's very important. Severity times probability times detection gives you a risk priority number. I did not make this up, guys. This is a real thing. Your severity can be between the number 1. Look, I'm going to do that weird math thing where everybody argues about math real quick. You know, the 7 plus 7 plus 7 times 7 times 0, and then everybody just shits their, can't remember how to do math. Hold on. Severity can be the number 1 to the number 10. Probability can be the number 1 to the number 10. And detection can be the number 1 through the number 10. So, if they were all 1s, 1 times 1 times 1 is equal to 1. And 10 to the power of 3 is what? It's 100, or it's 1,000, right? So this number, I don't even know. This number can be between 1 and 1,000. That's what this number can be, your risk priority number. Can't use 0. 0 would yield a 0, so, and it would yield a 0. I know people struggle, but 1, 1, 1 to 10, 10, 10, right? It can be anything in there. So now these are the same things that we just talked about, and here's like what I assess the customer impact, the likelihood. Maybe the likelihood comes from my previous last month of tickets that have come in from these, and maybe I just standardized this down, divided them by 10 or something, and I found one of the, this was 10, this was 20, this was maybe 50, and this was 40 of those, and that's how I determined my likelihood. Whatever, it can be, you can do any number of things, or you can histogram them into 10 buckets and use that, right? You do all kinds of things, right? Detect and react, and then now we multiply them out and we get a risk priority number over here. So the thing here that was the most problematic to us, according to this, is that the agent register fails. Avamar or New Relic or whatever. I almost said New Balance, but it's New Relic. Whatever our thing is, right? All right, so there's that. Come down here. A few other troubleshooting notes. These are important things to know. Your feelings don't matter. What you feel the problem is irrelevant. I feel like this has happened before. It's fine to say this looks like something that's happened before. But if you're like, I feel in my gut that this is a memory issue, that's not. You may be right, but the thing is that feeling in your gut is actually pattern recognition of you saying, I've actually seen this 30 times before, and every time a system shifts memory numbers very quickly and then drops out of Slurm and fails all the jobs on it, it's because of a memory DIMM failure. Almost, I mean, what I just described is probably the most common thing in a supercomputer that I've ever seen. One memory DIMM fails, it changes the ratio of CPU to memory inside that system, and literally everything in there is, I mean, it would be like if the tracks were 20 inches wide and all of a sudden they were 18 inches wide. The cart's coming off it, right? Something's going to break. I don't know exactly what, and it's going to be fantastic, but it's going to break, right? So anyways, my point is what you feel doesn't matter in engineering, and I've explained that to engineers over the years. What you feel is literally irrelevant. And then all anti-methodologies for troubleshooting. The blind man, we just flip switches, right? We're like Morty in the back, just flipping switches. It's bad. It's not a good methodology for fixing things. Spotlighting, only using tools you're familiar with. You gotta, if you run out of the tools that you know how to use, you might have to go figure out other tools. Although I often tell you guys, you don't want to be figuring out tools late at night when you're prone to failure, or when somebody's looking over your shoulder trying to fix something. And then another one is don't blame people up front. Gather information, look at stuff. There's going to be plenty of time to blame network later for their problem that they caused, but not now. That's not how we start. I always tell my engineers, don't blame networking teams. They're going to be so mad at you. They were already blamed before you got called out, right? So just don't hop on and go, this looks like the network. give them a minute or two to ease into it. You got to hire a psychic to assist with some investigation. Sure, yeah. I would say for sure, make sure you're getting your logs off your systems in real time. That's one of the big ones. That's one of the big ones that'll change your game. Is if you're good at getting logs off of systems, people are gonna like notice that you're much better at system solutions and systems engineering than maybe somebody who doesn't do that stuff well. All right, questions, drop them in Discord. All right, so what I was gonna do tonight. What I was actually going to do tonight was this. I was going to pull this up. Leave this here for a second. And I was going to go a little bit over in the in our Killer Coda site. We've got a bunch of different labs. And a while ago, I did a little series about what a Linux admin needs to know about security. And we just kind of filled this out as we went. So we might do a little bit of labs. I'll take a break here for a second, but we might walk through these labs a little bit, and we'll just ask ourselves questions like, where do we check for user alerts on logins? What is an invalid user? What does that mean? How do you add a user to a system? These are the things that we need to know as a Linux admin around securing a system for sure. So we'll do that a little bit, if that works. But before we do that, let me go pop on. I used to have this other one. Let's pull up my little thing here. Here's our hourglass. There's Ranger down there. Look at him. Look at that dog. And was it 7:14 and we still got all that sun? Man, take a break. And we'll do 10 minutes. I get a 10-minute break today. So you guys hang out. You guys watch Ranger for a little bit. Talk amongst yourselves. I'll leave Enzo Bear in charge until everybody gets back. Until I get back. All right, I'll be back. Go take a break. If you guys are watching these, trying to get in the field, you should be taking notes. All right, I'll be back. 5 minutes left of your break. Who's in charge? You guys all behaving in here? I'll wander around and grab me some more water. You guys saw we hit 4,000 people in Discord. It's pretty awesome. That's not really one of our goals, but that's pretty awesome. Our next real goal is 10,000, but 4,000's on the way, so we'll take it. Mods. There's no mods around here. My moderators, man. It's like me promoting somebody to moderator just means they're gonna leave. That's what it means. Enzo Bear. I can't mod anybody. So take a little bit more of a break, guys. I'm gonna stand on my slack block over here. If you guys have never seen a slack block, they're awesome. I can in one day feel my calf tightening up massively. Both my calves. Yeah, look up a slack block if you've never seen one of those things. Pretty cool. It's the best thing. I mean, it's like a slack line, but you don't have to be on a slack line. All right, where are we at? You can feel it big time in your calves too. All right, where are we at here? I'm gonna go here, and we're gonna turn this off, and we're gonna go to user login stuff. So, we're still on a break. Don't have to start just yet. If anybody wants to do the lab with me, here's the lab we're going to be doing right here. So if anybody wants to hop in, killer code is free, guys. It doesn't cost you nothing but time. You're already wasting your time sitting here listening to me, so you might as well be in there. It's free. I've showed you guys the only thing I get out of it, right? The only thing I get out of it is it shows me how many people have kicked off my labs. It doesn't show me who. It doesn't show me how often. It just shows me like an aggregate. If you guys have never seen it, it looks like this. It's actually a pretty cool thing. I haven't looked at it in a while, since we still got a few minutes of break. Should be under creator. Go to activity. This is the only thing I get out of this, is the joy of knowing that people have been jumping into. In the last hour, nobody's really hopped in anything except the system checking lab. And then in the last 7 days, we had 120. And then in the last 30 days, there's been kind of ups and downs, right? I haven't really been pushing labs, but I'm going to be focusing on the book more here soon, so we'll probably be doing a lot more labs. But yeah, we've been averaging over 3,500 labs, over 3,000 labs a month all year. That's good. Hopefully people are learning stuff. That's the goal. Get people in there. It's free, right? It doesn't cost you nothing. So we'll get in there and do that. What else? Am I missing anything? But Enzo Mary, you're right. Yeah, my mods are not around. I don't know where my mods are. Who knows? Mods could be anywhere at this point. Mods could be anywhere. We'll wait the last 2 minutes though before we start up again. So in case somebody took a break or went and walked around, they don't have to feel like they're coming back and I lied to them about 10 minutes. You guys want to see my arm? Yeah, I took a pretty good spill. Took all the skin off my arm. I was, you guys seen my drift trikes? Yeah, those are pretty fun. They're basically big wheels for adults. And we were out riding them this last weekend. We had a big party over here and it was pretty fun. And I meant to take more pictures to show Discord, but I didn't take them all, so. All right, 1 minute. 1 minute. We'll do some labs. We'll talk about security, right? Because security's been a major focus for us. We've been doing, even in the admin course, we hit a lot of security. And then we did a security engineering course where we did all security. And the goal is to get you guys into doing this stuff, as a professional, right? Seeing what do we do? What's it look like to deliver this to a customer? Whether the customer's internal or customer's external. And they're, an external customer is still the one paying you, so you want to keep them happy. But yeah, what does it look like to do this stuff? And I think this is valuable. So, all right, wait for the break to be over, and then we'll go. I've linked in the chat if anybody wants to do the lab. And I said linked in the chat. I didn't say LinkedIn. Not a place where everybody can contribute. You guys have no idea how much that bugs me. You couldn't possibly know. I always tell the wife stuff like that. I'm like, you couldn't possibly know. And it's kind of funny. But yeah. Probably have to be there for that one. But all right, so wait for that. Stop. Go up here. All right. So in this lab, right, your security operations team has informed you that an alert for unknown users has gone off for your Node 01 instance. So that's some instance in the company, Node 01. So you're going to connect to that server, Node 01, and look at the appropriate log to determine login attempts. So there's some log there, and you need to go and look at it and figure out what's kind of going on, right? Add the number of attempted logins into a file called root attempts, and add the usernames into a file called root users. Okay, I think we could probably figure that out. So let's go to our solution. We SSH over to Node 01. That makes sense. And we look at varlog authlog. And in here, we see that there is a attempted failed password for invalid user suspect 1. There's a failed something for suspect 2, for the user suspect 2. There's this failed password. There's a failed password for suspect 3, right there, and right there, failed user suspect 3. And then there's a failed user and failed password for real user. So suspect 1, 2, 3, and then failed, and then real user. So I want you to think about this. It says right here, what are the invalid users? Is the answer those 3 suspects, or is it all of them that are invalid? And I want you to think about that. Does the name of the user matter to whether or not they are invalid or real or not, right? Another way to think about this is look in my home lab here. These are actual people that have tried to get into my system in the last 6 hours. Root is a valid user, right? Isn't admin maybe a valid user? It's not in my home lab, but it could be. How about root? Here's root again. Here's Jira. Jira could be real. Jira could be a real user in my environment. It's not, but it could be. Test. Test is a common one. Pi. Maybe I'm running Raspbian, and they're trying to get on my Raspberry Pi. Admin test. Bunch of root. That person got kicked out forever. 1, 2, 3, 4, 5, 6. Gone. Your IP's never coming in again. All right. Anyways, all that to show you that we can look at this stuff. Hey, thanks for the follow. I don't know how to say that. Holappins. Hopefully this stuff's useful to you. So anyway, so we go look and we see these errors. We see this user. So now we could also just check invalid, and we see invalid suspect 1, suspect 2, suspect 3, and real user. And the answer to the question is all of those are invalid users. Even if it's got the name real user, it doesn't matter. That's a user that our system doesn't recognize. That's a problem. Now, could these all be real like login accounts and your system has lost authentication up to the organization's trust? Sure. We might have lost LDAP or whatever single sign-on IDM or whatever solution we're using to talk to the enterprise and know what the users are. Sure. So these might all be valid users in some context. But I know for right now, my system sees all 4 of those as busted users that do not belong. Okay? So it's very important. So what I can do is I can exit back here and I can just grab all of those and throw those into a file called root users, which was one of our requirements. Throw all the usernames into a file there. So we threw those all in. And then we can echo 4 into root attempts because that's the number of attempted logins. Attempts is just the name of the file. And we've now checked and our validation is successful, so we can go forward in the lab. Now you check with your security team, and the one user that's supposed to exist, the one user that's okay to have in your environment, in this lower environment, is called real user. So it says here to create a real user account on both systems and ensure that root can log in as that user. All right, so our root user needs to be able to log in as that user. Now again, we might not always do this, but this is valuable to understand. Also, over here as we're looking at this, you could be taking notes. Where do we check for user alerts on logins? In Ubuntu, it's varlog authlog. I have no idea why that showed up again like that. It's varlog auth.log. And rel is varlog secure. So if you're in a rel system, which you'll commonly be in your career, varlog secure. So varlog auth.log and varlog secure are where we send alerts. Now, not that it's part of this conversation, but maybe this is another thing we want to know. Where do we check? And maybe I say, how do we check that configuration for logging? And that would be in etc rsyslog.d .conf probably. So we'll go check that here in a second. Let's come down here. Let's move all these up. This is just a notepad, so we don't have like a great functionality of this, but this is still, I think, useful. And then I always put these notes up in the Discord. However, that being said, guys, I still think you should practice writing. If you say, Scott, I'm not good at this stuff and I want to learn it, well, don't just trust me to take notes. Write your own notes. I promise you will remember things better if you write your own notes. Hayes, what'd you get at Taco Bell? That's the important question. Also, can I tell you, I don't think I've like purposely ate Taco Bell in a few months, but it's because it's so disheartening. I used to be able to go to Taco Bell when I was younger for like, I don't know, $6 or something. And now the thing that I like the most at Taco Bell itself costs like $7. So that's one disheartening thing. I'll tell you a few of them, Hayes. When I was a teenager, I worked at Taco Bell. I hate that they got rid of their green sauce. You used to be able to ask for green sauce on everything. They got rid of it. I hate that. Well, and I hate that for another reason. That used to be the sauce that was on their quesadillas, their chicken quesadillas. Now it's not there anymore. Now you have to get their creamy jalapeno or whatever. I don't like that. I used to always get the green sauce. You got a bean burrito, no onion and beefs. Okay. That sounds pretty good. But I used to love getting their 7-layer burritos over there. 7-layer burritos were good. 1988. Yeah, I worked there. Would have been like 97 or 98. So I was like 16, 17-ish. I had a... What else at Taco Bell? Oh, yeah, the other thing they got rid of... What did they get rid of recently that me and the wife were talking about? Oh, anyways, yeah, but their chicken quesadillas, you can't get a chicken quesadilla for under like $6.50 now. And I'm like, dude, I just want this one little. Use large in the beans. When I was there in the 90s, the beans came as like they look like cornflakes. You seriously could throw them in your mouth like little cornflakes, and then you would put water in them, and they would turn into beans. But they were so dehydrated down that they had no liquid in them. So yeah, that was a thing. That'll keep you from eating there too much. But I don't mind Taco Bell. I just don't go. It's so, yeah, the verde sauce. Yeah, that green stuff. I would put that in my bean burritos too. I loved it. But can't get it anymore. All right. Anyway, so they got rid of it. Yeah, a few years back. Yeah, we might not always do all these things, but this is important. Okay, so how do we check that config? Let me show you guys this real quick. So if I just, let's say vi etc rsyslog.conf real quick. And down here, you're going to see the configurations. Oh, where is it? It should be, where's it at? Maybe it is an etc syslog.d. Let's go see. Oh, well, maybe it is in here. 50 default. I guess they have broken it out now. Here's the auth and auth priv. So everything auth or auth priv. So something.conf, something in here will have it, right? And some systems will do it down here, and again, some systems will do it directly in the etc. But this is the auth and the auth priv. That's what's going into varlog auth log. So if you ever said, hey, Scott, could I change a system so all the logs go to one place and then get sent out of our syslog? Yes, you could. It's very simple to do. So this is a very kind of important thing to know about as a sysadmin, but you may not ever change this in your career as a sysadmin. As a systems engineer, you will change these things. You will configure these, and you will send things to different locations. And we actually have labs that show you how to do that, right? We have other labs that show you that. But how do we check that configuration for logging? It's right in here. And then if we want that log to send out somewhere, we can set that up. And I have other labs that show you how to do that. But all right, so let's get into this one. We look at the ID for real user, and it's on this system, but it's not over on node 01. So let's make the user over on node 01, SSH to node 01, user add -m real user. So we'll make that real user over there. And then I say right here, normally we wouldn't do this part. This next part isn't really something we do. Some lightweight directory authentication protocol or outside authority would give the user a password, but we're going to go set the password for real user to be 1234. That's we're just going to send them some simple password. And then we're going to exit back out of node 01 and we're going to wipe the log over there. This is also something we would normally never do, wipe a log on a system, but just for testing here we'll do it, right? It'll be fun. And then now we're going to rerun our root SSH script, and that takes a few seconds, maybe about 25 seconds, to do all of those logins and failures again for the users. And we're going to see if we still see real user in that log as a failed invalid user. We might still see failures, but we will not see an invalid user now. So that runs, and we'll go check, and now we only see suspect 1, suspect 2, and suspect 3. We don't see that other user in there like we did before, right? So this is kind of an important thing to understand. You'll still see errors with the login if you go look, but real user is no longer an invalid user. So an invalid user is really, you should watch for users that are trying to log into systems that are valid but are doing bad things, like getting themselves locked out. That's still something you should monitor for. But invalid users are another thing that should trigger immediately. Somebody's using a user that's not even on the system. Somebody's trying to log in ES on all of my boxes, and you go, what the heck's an ES? Elasticsearch, it was a very common username for anything that had open Elasticsearch. Nagios, very common one. Pi, very common one. If you're running Pi, any Raspbian Linux, it's probably on. This is one of the reasons why we always change or disable all default accounts inside of a system. Never run default accounts, right? Especially through SSH. Don't even allow them in. So, all right, so we did all that. It says, how do you add the? So what's an invalid user? When you do an ID for a username, it gives no user. When you grep username out of Etsy passwd, you find nothing. So again, these are security questions that we would ask ourselves. Do I know how to do these things? Do I know where to check for alerts if somebody can't log in on a system? If somebody's trying to log on an Ubuntu system and they can't get in, I'll go tail this log, hit enter a few times and say, hey, can you try to log in? I want to see what that error message is that they're getting. The user can't see that. They don't even know that exists probably. So your job is to track what's happening. Oh, you guys pressure cooked the beans back then, Hayes? We used to just pour them in the thing, put the top on them, and let them heat up for like 30 minutes or something. So they would just heat up. Yeah, I don't think we pressure cooked them or anything. Hayes, were you around for my arm? Did you get to see my... Got a pretty good raspberry on there. It's pretty good. That's about, I don't know, not quite the length of my finger or so. A few knuckles. Yeah, I fell off one of my drift trikes. Well, but to be fair, I protected my friend's truck because I don't have any brakes on my drift trikes. So, anyways, all right. What's an invalid user? A user that doesn't exist, right? How do we check for them? Boom. How do you add a user? User add -m to make sure it creates the home directory. How do you set the password? Passwd real user. How do you check that the real user password has been set? So SSH to node 01, CHAGE-L real user. That'll tell me if the password's set on that user or not. Last password change today. That's tomorrow, but they're on UTC time. So that's fine. They're in tomorrow for me because it's only 7:38 here, so it's not that. Yeah, Hayes, I've never broken a bone, so I can't imagine breaking one just falling. I mean, you'd be falling that far because you're literally that low on a drift trike. So some of you guys have seen us riding the drift trikes and stuff. We got them in the Discord a few times too. But anyway, so how would you lock the user account? Password -L real user. How would you unlock the user account? So password changed, and then if I go look, I would see if the account is there, and if I try to sudo for SU dash to real user. Oh yeah, well, because I'm not using a password, that's fine. And then if I needed to unlock the password or unlock the user account, then we would be there. All right. So how would you lock or unlock? Pass WD-L and you can lock or unlock users. Now, setting the password complexity rules, how would you do that? We could go into etc pam.d system auth. So maybe. Yeah, there we go. Maybe we don't have him in there. Let's go see. Oh, we don't have any system auth in here. We do in all my Linux boxes. Hey, there's Robodom. How's it going, man? There was a mod check earlier, and I was like, my mods are never here. My mods are always busy. It's okay. But yeah, we're just hanging out. Robodom talking about some stuff and working through some stuff. Yeah, talking about how great the mods are, yeah. I said every time I mod people, they leave forever, so I don't mod people anymore. I think Robodom's the only mod that's still around. Everybody gets busy, so it is what it is. Can you generate a key pair? Yep, SSH keygen. Can you find out where it was generated? Yep, real user. Can you check out the public versus the private keys and that their permissions are correct? Yes. That's the next part of the lab. So real user is now set up, and we're going to create a key for the real user called real user RSA. So I'm going to CD back to root real quick so I'm in the right spot. And we're going to try to create a key, but I'm going to make the key this right here. Root real user RSA. So that's where we're going to pass it. And now if we ls-l on root.ssh, we'll see that there's real user RSA, which is the private key. He is 600 permissions, meaning nobody else can read it besides root. And then his public key, real user RSA, is 644, which means anybody in all the world can read it. Anybody can read this. Go pass it out far and wide, doesn't matter. You got busy at work, Hayes? I've been super busy the last 2 weeks too. If you guys have noticed, I haven't been streaming as much. It's because I've been on call and just keeping everything going. And then I've been doing my doctorate as well, so that's kind of busy work. And I have more posts. I got posts to make tonight, so I'm busy on that. And then what's the other one? I've got yeah, work's been busy. Oh, and then college teaching is always busy. Like I'm always busy with my students. I got a lot of students, so. Yeah, we stay busy, but you know, this is one of the reasons like streaming is like, this is just a vehicle to me to go tell people that we've got a group. The main focus for me is the Discord, right? I want people down there. I want people to know that they can hop in there and talk shop with other people, and they can work on their business etiquette. Some people really need that. Some people can work on their Linux, right? Linux and projects and labs and all that kind of stuff. We make a concerted effort down there to teach people like standards for being Linux administrators and all that kind of stuff. Johnny, man, how's it going? Yeah, Enzo Bear, I get it, man. I'm tired right now. I go wrestle in the morning, so I do jiu-jitsu at 5 to 6 a.m. Well, Brazilian jiu-jitsu for anybody that cares. I do that from 5 to 6 a.m., but then I have a call right at 5, so I did like the class this morning. Me and one of the guys are working, and then I had to go step off and take my call. Normally it's like a 5 to 10 minute call, but one person wanted to talk really long, so it was a 30-minute call and went all the way to the end of class. So I didn't get to do any wrestling this morning, which kind of sucked. I have a whole bunch of stuff I want to work on and only so much time to do it. So I'm going to go tomorrow into the open mat at 5 a.m. That'll be fun. So, all right, nobody cares about that stuff. But the point is, can you create a private public key? Can you copy that key over to that user via their password? So you need to know 1, 2, 3, 4 for their password. And now you can use that key. So if I say, who am I? And ID, I'm the root user, host name. Oh, you know what? I did it on the wrong system, but that's fine. Let's just jump over to that user, and then now I'm going as that user and checking. Yep, there's the real user ID over there, whatever. So you're able to create and push over a key pair. Now, if you're on this system, right, now you're back to the root user. If I sudo up to real user, show you guys something real quick. Oh, that's awesome. Let's get out of here. That's not going to work. SU dash to real user. You want the dash because it'll make you actually the user. So then I say pwd, and I'll see the .ssh. So cd to .ssh in my home directory, I can read it. And I've got this authorized keys. And if I exit out of here and I were to cat the, what the hell is that, real user? .pub, it's going to be the same value as what's in that auth keys file right there. So those are the exact same values because the authorized key is simply the public key that's been placed in that system. The public key placed in there, it's much more analogous, even though it's called a public key, from a cryptography standpoint, that's what it is, but it is much more analogous in our minds to like a lock, like a padlock that you put out there, and then you've got the one private key, which is much more analogous to an actual key that goes and unlocks the padlock. Because the cryptographically similar authorized key there, the one that's over there, is the public version of the private key that only you hold. You can always generate public versions of a key from a private key. You can never go the other way, though. It's a one-way encryption, right? So what they call a one-way algorithm. So, all right. Troubleshooting key files and where your problems are. If you go mess around with this file and if you modify that to have different permissions, it's not going to work. Your system won't read it. If your public key is well, that's always going to be open, but if your private key is like 644 or 666, it won't allow you to use that key. It'll say that key's too open for us to use. So that's a setting in SSH client. All right, so anyways, that's that whole lab. That's pretty much all those things. I put this up in the notes typically so you guys can have it. Let's save that. Why is that showing up like that? I would have thought as long as I saved it. Okay, anyways. So the next lab is attempted sudo access, which is a very similar type of lab. And some of you guys have done these with me before, so you've seen these, but I think that this is really valuable. Hayes, you said you're slowly but finally figuring out how to do your job. Yeah, it sounds like, Hayes, from what you've told me, it sounds like there's a lot of change management needed. Or if change management is happening, it's also still needed because it sounds like it doesn't happen enough. Like you were saying, how you were trying to wrestle down your environment and get certain things to work and stuff. And some of that gets better. You know, sometimes engineers hate change management because it slows them down. But sometimes if there's too many cooks in the kitchen, it's nice to have somebody guarding that pot. If you've ever heard the song Too Many Cooks, whenever we used to have problems, one of my buddies, Dave, used to always, you know, we'd be sitting there trying to fix something and he'd be over our shoulders just humming Too Many Cooks in the kitchen. Sometimes he'd be flat out singing it. But once we knew the song, he didn't have to sing it anymore. He'd just hum it and we'd be like, because the point is too many cooks in the kitchen gives you, you know, bad soup or whatever. They actually did that on an episode of Frasier, and it was really funny. If you ever get a chance to go, like, a lot of shows don't, like, I don't think stand the test of time. I don't think a lot of shows are funny later. Frasier's still hilarious, like, 30 years later. I laugh my ass off. I just rewatched Frasier, like, a year ago. Laughed so hard at that show. Anyway, so let's go down here. Let's talk about, you have unusual user behavior, attempted sudo. So the user's trying to do stuff. And it's not always a user. Sometimes it's a process. Sometimes it's actually like a service account. And sometimes it's not even doing something it's not supposed to do. Sometimes it's valid, right? Sometimes there's valid stuff. So let's try this one. If anybody wants to do the lab with me, there it is. And it says your security operations team has informed you that there's an alert for sudo activity that's happened on the server. Hopefully your security operations team is that on it and you don't have to find it yourself. But investigate the sudo logs to see what the user is attempting to do. So this user's doing something they're not supposed to do on your system. So we're going to go look at what's going on in this system. That's the goal right here. All right. When this is done, we'll say, give the system a little bit of time. And if you can't give it time, go ahead and wait 60 seconds because there's something going on in the background that we have to wait a minute for it to go off. You have to work on a rack where someone else. That's true too, Enzo. Yeah, I'm not a big fan of like getting in and out and moving stuff, especially if I have like a cable. Like I have to have a cable and then I'm over like sitting and people are like walking past and you're like, oh my God, please just walk around. Like you are going to catch your foot on this cable one of these times. And you say, well, you shouldn't have your cable across. Yeah, you're not living there. You're just parked there for a little bit working on stuff. But people don't pick up their feet in data centers. I don't know what it is. I don't know why it is, but it's true. Yeah, people start stepping on each other. Yeah. It's there's a higher chance of errors when you have to do things different outside of your normal routine. That's 100% true. So this system's going to come back up. We're waiting on the sleep to be done. And when we're done, we're going to check the logs where Ubuntu keeps sudo requests. And we're going to look for problems. So something's happened. There's a session that's been open for bad user, session that's been open for bad user. And it said the user is not in sudoers. That's not good. And then the user also didn't have a password for bad user. So this script is having multiple things wrong right now. But first off, this bad user, remember I said earlier, the name doesn't really matter. This just happens to be bad user for the lab. He could not identify with a password and he's not in the sudoers file. So he's trying to do things that he shouldn't be doing, right? Now again, I was telling you guys, sometimes a service, service account or like some dev team that you have, they may try to run something that a vendor gave them. The vendor will be like, well, just run this on your machine and you'll have everything working. And they'll try to do that in a dev environment and they don't have permissions because you don't give them all root, right? That'd be madness. Don't give everybody root. You'll have a fucked up environment. But maybe they do deserve some of these permissions, so we do give them to them. So we're going to look at that here in a second. But we can see that there's errors in the system, and we can see that there are messages in here about the user trying to do things that they shouldn't do. Yeah, damn vendors. Always telling our users to do stuff. So let's look at bad user. In varlog syslog, he's got a whole bunch of messages. And in varlog authlog, he's got a bunch of messages around sudo and not being able to be in there. Okay. We'll see bad user not in sudos. Yep. Here's the actual commands he's trying to run right here. Right, and he's trying to use a password to log in as well. So this indicates a user is trying to sudo and use elevated permissions that they do not have. So sudo is a tool. It is a way to become a substitute user on the system. SU is actually substitute user, and sudo is a way to become the root user on the system, right? So they are trying to escalate or elevate their privileges, whatever you want to call that, elevate their privileges to the root user for fun and profit, right? For whatever reason. So we can either then give or remove their permissions. And let's go look at cron tab to see what's happening. Yes, so see the root user is running this every minute. It's running these two commands. So now let's go look at the bad user. We find out from security is allowed to have permissions. Maybe your manager has worked with their manager and said in the dev environment, we'll go ahead and give you these permissions. It will always, always, always cause you headaches when users get more permissions. You say, I don't believe that, Scott. Well, that right there, dealing with users is why every engineer and like older person that's in tech is salty. It's because of users. And you say, yeah, but it's actually their coworkers. It's their coworkers being users that don't know how to use the system that bugs them. Or it's their coworkers being users that are unaware of how to do things properly that bugs them almost universally. So people that have been in tech for a long time, they're like, these damn users, these damn whatevers, they don't do anything. Well, I'm just telling you, you can be very cynical in this world, right? So there's many ways to give sudo permissions. We're going to give them directly in the sudoers file by putting the user in the right group to start. So that's going to be one. So let's cat etc sudoers. And this is the file that defines user permissions in our system. There's a bunch of settings that we can do in here, but what we care about for right now is this user either admin or sudo. And here's the root user being given all permissions. And these are groups. So the little percentage sign in front of this says that that's the group admin and the group sudo. So we're going to come down here and we're going to give the bad user the secondary group sudo. So if I do an ID on bad user right now, he's not in any special groups. He's just in bad user. We're going to run this command to mod the user, and then we're going to check the user again, and now he's in the sudo group, right? Now, if I grep bad user from etc group, I'll see him in there under that sudo. If I do a sudo -l-U bad user, I will also see that he has the permission to run all of these commands on the system. However, he cannot do them without a password. He needs a password still for himself, so he's still going to be failing right now. We got to give him a password for this to finish working. So, yeah, Enzo Bear, thanks for coming by. I appreciate it. Xshunny said control freaks make good sysadmins. Yeah, I think there's a certain amount of truth to that. You have to have like a, I don't know, I would almost call it like a righteous indignation about how people treat your systems. It's like if somebody just walks in your house and just starts stomping mud into your couch or something, and you're like Eddie Murphy and Charlie Murphy, Eddie and Charlie Murphy, when they like beat up Rick James and like punched his legs a whole bunch because he was grinding his boots into their couch. So that's exactly what, you know. Anyway, so that's kind of funny to me. But anyway, so bad user, and then we checked for it, and then we maybe sleep for 60 seconds if we wanted to, or we'd sit here and talk. And then when we're done, we'll tail those logs again and see if there's still errors. There will still be a bad password, but there will no longer be the not in sudoers file. That's not going to be a real thing anymore. So let's let that run. Oh man. Also, it's like almost 2.5 hours, so I might be getting off here soon. We'll let that run, and then we'll finish this one up, and then we'll go about our different stuff, right? All I've been focusing on the last few days is like the skills that I think you need to do to get into the field. The things that you need to know, in this case, about security as an admin, right? The things that you're going to touch, things that you're going to mess with, and show you guys all these different places you can go look for them, right? We also have courses up in our Discord that are free that cover not the same exact stuff, but it's the same spirit of this stuff, right? In fact, I think in the security engineering course, we didn't even touch sudo because it's just one of those things where it is valuable, but we didn't touch it. We just didn't have time. We can only do so much. So we're going to tail 20 and tail 20, and we will see that the user's still having problems logging in and doing things, but it's no longer that he's just having bad password attempts. It's not that he's not in the file anymore. I said, what values are you seeing in there now regarding the bad user account and sudo access? Well, he still doesn't have a password, but there's no failed user is not in sudoers anymore. The user is in sudoers. He just doesn't know his password. It says, has it now successfully performed the sudo commands? No, because it hasn't been able to log in yet. So now we need to give that user a password. So we're going to do password bad user, and we'll give him password 1234 because that's what the system's using. So over here, 1234. 234. Doesn't echo to the screen, so you can't see how long it is. And then there's that. And then we should be able to move forward. And it says now we've given them all the permissions, so we'll wait a little bit here. And this is kind of important. We still have the sudo -l-U bad user. He's still able to do things now. But now that script is no longer going to throw errors. It's going to allow that user to do things. But do you see right here how it's all? Does it make sense that, like, if I was going to give you... Has anybody here... Like, this is going to be a weird one for people outside of the U.S. Is anybody here that doesn't mind telling us outside of the U.S.? This will be a little weird for people, maybe. People inside the U.S., it's going to be a little different. It might still be weird for you if you've never done this. But I'm gonna use a gun example because I'm an American. I've been shooting competitively since I was 7 years old. So long range precision rifle, right? Has anybody here ever been to a shotgun range? You guys ever been? It's almost like a mini golf, but with shotguns, and they launch the little discs. They launch the little discs, and they'll roll them along the ground and do all kinds of stuff, and you guys shoot them with a shotgun. Anybody here ever seen that? When you go to fire your shotgun, you're in a window. There's a window like this. And if you try to swing your shotgun either way, you'll hit the window before you'll point back at people behind you. I don't know if any of you guys have ever seen that. But that's like what a shotgun range is like. Yeah. They could be clay pigeons, or sometimes they're just discs. And they will launch them. They'll roll along the ground. They do all kinds of weird things. And you launch them off, and then typically you pay like 20 cents a disc or something. And then, but the point is, you're standing in a window, and you only have a limited field of view. And if you try to point that somewhere else, it won't. You can't do it. You'll bounce off the window. And they do that. It's like a window frame. And they do that for your safety and everybody's safety, because people get all excited or whatever. Okay. I mean, I don't think you should get that excited, but some people do. So it protects everybody, right? So where I'm going with this is, we're going to put that window around. We're not going to give you the ability to just swing that shotgun everywhere. We're going to point you in one direction. You're only going to be able to do the two things that you are required to do as that bad user. So this bad user is a service account for our, maybe we have a badminton dev team, and that badminton dev team is making the cool badminton game. So they've got a user called bad user, because that's the best thing they could come up with. And now we've given them all the permissions, but we don't want that. We're going to scope their permissions down to just what they need, right? Let's do that real quick. So we're going to pull the user. So we just did a sudo -l. Let's remove the user. Sudo -l-U bad user again. And we see that he's not allowed to run sudo again. He's been nixed. He's bad. But now we're going to go give him, down in the etc sudoers.d directory, we're going to make a file for him right here. And if we look now, bad user is now just a regular user in here. This is going to be appended to the end of the etc sudoers file. The sudoers.d, everything gets appended to the end. Bad user is allowed to do all with no password of when they want to do user bin ls root or just user bin su dash. That's all. So all they're allowed to do. And if you say, well, how did you find those paths to use? Well, they're right here. You can always do a which or where is, and it'll tell you where the commands are. So that's how we know user bin ls and user bin su, right? As opposed to being in like user sbin or just sbin, right? So we go and look and say, yeah, we have all the passwords, all the commands that we want to run here with no password. We don't even need a password to do user bin ls root or user bin su dash. Which, by the way, that lets you become root, so that's giving them the whole thing anyways, but we're not here to worry about that for this lab, right? That's just a thing. So we come down here, how do these permissions compare with what was given before? Well, before we gave them everything. Now we're only giving them the specific commands that they should have. We've scoped them down. We've used what's called the rule of least privilege, right? So we check it. It says, look at you learning security. So over here, we say, how do we give sudo permissions? We can give it directly in the etc sudoers file, or we can give it in etc sudoers.d some file, right, with whatever name. How do we check the user's permissions? Is very important. Sudo -l-U and then the username. Probably one of the most useful commands I've ever run into in my career, because often I have to just audit what's going on. Somebody tells me something's wrong, and it's very vague and it's very whatever, but I know to go look for the permissions. Is the user showing up in the logs trying to sudo things that they shouldn't? How do I give them permissions? Do I go check another system? A lot of times people will tell you in a ticket, I need the permissions like this other one. And then you go over there and you find out what somebody else did. Did they give them an etc sudoers.d? This is the way I prefer to do it. And you might say, why do you prefer to do it here and not do it directly in sudoers? Well, the reason I prefer to do it here is when I go and deploy this server for them in the future for my automated process, if they're always going to need those sets of permissions to always install that tool, or even if I'm going to use a service account to install their tool, and maybe I use their account to do the kickoff of the playbook, they're going to need those permissions. So I drop etc sudoers.d sorry, etsy-sudoers.d/bad user as an Ansible play, and I just copy it over from my local repository of all of, and sometimes I'll even keep them up and get all of my different user accounts that can go in there, and only the users that get tagged to go on a server from my build process are the ones that get dumped in there. It's kind of a nice little way to do security because it's very granular, but it's still automated. Granular is hard to do in an automated fashion unless you kind of get used to doing it the exact same way, and then it becomes super easy. Super easy. This is where you put the file. This is how you test it. Now you can automate it, right? Yeah. So what do we mean by scope in the permissions? So rule of least privilege says don't just give everybody everything. Don't just give them root. Only give them the permissions that we intend to give them. So there's that. All right. How's the ranger doing? That dog. He's getting so old. All right. So I'll probably stop here. This is up in the Discord already. I think this is up in meeting notes from a while back when I did all these. I have more to add to these, but these are just things that I think a security engineer needs to know, right? You need to know when the system was last patched. You need to know about the kernel updates, and then you need to know what does update do inside of Ubuntu. It only updates the metadata. You got to do upgrade to actually finish, right? How do you see what is upgradable? The upgradable command. Why do you care about the size of the downloads? Well, you might be running out of space in var cache DNF, so maybe you need to wipe that. There's just a whole bunch of things that I think as a sysadmin you need to know that are actually more security focused. Yeah, this one was update golden image. So, all right. So we basically talked about all that stuff. I think most of you guys that are around probably know that we hit 4,000 users in Discord, so that's kind of cool. You guys are welcome to hang out down in Discord. Probably even have more now. Look, the guys are still down there studying. You can go study with them if you want. Those groups, like I purposely stay out of those groups because I want that to be the community. I want that to be the people that do it. Sometimes I pop in when they're done studying, but I don't want people to just think like this is the Scott show. That's not the point. The point is you guys can go in there and do stuff. Yeah, we should be well above now. Yeah, we're pretty far above, but okay. Twitch schedule. I don't know why this thing isn't going to streamer mode lately. It hasn't been going to streamer mode. All right. So, that being said, tomorrow, I should be on for a little bit tomorrow. We're going to do, oh, gosh, you know what I've forgotten? I have to record Unit 10 of the security engineering course still, and I have to do that before Saturday because now I'm like 2 weeks behind. But I will get that recorded. Let me soft commit to do that Saturday morning. I got a little time Saturday morning before my college class, so I'll probably do that. It's going to take me 2 hours to do that. Yeah, Robodom. Yeah, we've got a lot of stuff going on, man. A lot of things. I've got a few more guest speakers that are planning on coming to our discussion for the in August. We have our big. This will be 11 years that we've been running the group. At least 11 years. I mean, we just officially say we started in 2014, but I think we were meeting before that. But we just have officially said that we started in August of 2014. But I'm pretty sure it was even before that. And then we have what else? We're doing the 6 years on Discord. 6 years that we've been playing around on Discord and showing people around Linux. So there's a lot of stuff up there, right? There's a lot of stuff to go look at and study and figure out and all that good stuff. So, yeah, I think it's pretty good, Robodom. I think it's a pretty good little thing. Also, Robodom, the guys were talking, we might start studying. I might have some study groups. They'll just be, not impromptu. I'll put them on the Discord, but they won't be like recorded or anything. But I'll have some more study groups for security stuff. So I don't know if you're still interested in doing any of that stuff, but there's a certified in cybersecurity cert that we're going to have, and people can work on that if they want. So 6 more years. Yeah, absolutely. Yeah. We'll keep doing it as long as we can. So what else? Yeah. I'll probably call it here, but You guys are welcome to hang out and do Discord stuff. I think that's the best place to be persistent and really focus on this kind of stuff. Find other people that are doing things that are similar to what you guys want to do. Yeah. So, yeah, I appreciate that, Rodom, definitely. Yeah. You're never gonna. Well, I mean, I don't know when most people are gonna stop learning this stuff, but I'll tell you, I still learn stuff, and I've been doing it for um, almost 25 years in systems, and Linux for about 22 of them, and I've been a college professor for 17, and I still haven't learned everything. Or maybe I learned it all and forgot it or something. I don't know. But anyways, the point is I don't know everything, so I don't think like maybe most people, because I'm kind of like always working in this space. So, but I do definitely think it's something that's attainable for the average person. You just got to spend time with this stuff and really start getting in here and working on it. So, all right, let's check on Ranger. He's tired. He's an old dog. All right. I'm going to go to end of stream. I appreciate you guys coming by. Over on the YouTube side, I've got nothing extra for you. Just hop in the Discord, please, if this is something that's good to you. On the Twitch side, we'll go find somebody to raid. Who's up and raiding? Who's up for raids? Nope, nobody I know is on doing any raids. So we won't worry about the raid tonight. We'll just stop it here. But I definitely appreciate you guys all coming by. And I will see some of you guys later on, maybe tomorrow. And definitely Saturday. I'm sure people will come by while I'm streaming for the recording. So, all right, take care, guys.